Hey guys, anybody there? Give me a second to figure this out. Everybody on my own channel, right? Come on, Kenzie. That took a minute to get here. Hey guys, that took a minute to get here. All right, now I'm here. That took a minute to get here. Hey guys, that took a minute. Feedback. It's not going to work. That took a minute to get here. I've got to grab a earpiece. I got it. Trying to remember how I did it the other day then. I was able to. That's weird. Let me try this. Okay. Mic on. Huh. That was weird. Kai, well, what delay do you have on? I don't have any delay on it. It's immediately, but it's Google put a 20-second delay on it anyway, just about. I'll give you a test on that in just a second. You can tell me. I'm going to let's see. How did I do it last time? Clap and then start counting. Let me see if that works, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have to tell me when you hear the clap. 11, 12, 13. 14. Okay, let's start over. Tell me. Yeah, I'll clap. Tell me when you hear the clap. I think I just clapped once. I'll click my fingers this time. And when you hear the click, let me know. I'll also start counting immediately after. You'll know the delay. I'm going to start it now. Ditto. How about now, ditto? It sucks. Let me get my cell phone on and make sure we got sound. I'll start over. Community, let me find this. Oh. Okay. Let me turn my cell phone on here, and I'll be able to watch it, and I'll put it on the side. And if you guys say no sound again, I'll see it hopefully sooner than having to flick over to a tab. Let's see. Live stream, community, live stream. I've got to load it on my cell phone real quick. Rat Boy 440. Hey. I was chatting my ass off too. I told you guys where the bodies were buried. I forgot now. I got amnesia. Come on, this damn thing. Still loading it up, guys. Trying to get my cell phone to find the event myself. And there it is. Give me a second to get it going. Come on, live now. Go. Cell phone. Okay, loading. All right. So now I've got the live chat on my cell phone to the left of me, so I can see you guys in real time. And somebody just said late, right? All right, bouncing back over here. I'll start over. Scrolling over. I don't know where I lost, so I'll just start from scratch. Can somebody put the time? Oh, you don't. There's no time on this video, so we know to tell people to start at this point. All right, what I was saying is I'm gonna grab stuff off my Seagate drive. I'm gonna show you guys my data off of here, and I'm gonna share some of the things I never put on a video before. Then we're gonna look at the report again. I fell asleep on this, as I said earlier, last night, looking over these things all the time, all through the night. I have a problem sleeping. I have a sleeping disorder. So anyway, wake up, look at this immediately, and start working on it and fall asleep on it again. With that said, this is Ntsb's report, right? This is a technical report. And what do we have here? Their sourcing of this material is Manila Construction Management. This this source is not the inspecting engineer. We have the image down here. This is the internet. The source is not Manila Construction. As you guys know, I talked about the drone video. I did a whole thing on a drone video showing the guy with his shoes and how he appears to be the person they use, just for data, and saying how they kept looking at this end, that apparently this end is very critical, and they were scully all around there at nighttime. And the process came to an end for a moment, and I said all eyes seem to be concentrating down at 11 at this end of the structure. As you can see, the people in a circle and triangulate their heads, right? So anyway, source internet. Manila is the source of this. They're the only ones I know with a drone out there at the time. So they're changed that this Ntsb has now decided this is internet. Let's look at the source of the ones above. Source Manila again. Manila is sharing this again, not the engineering company. So Manila is proactive, if you ask me, or they're saying Manila doing to leave away the engineer. I don't know what Ntsb's motive on that one is. Here's source Bolt, Perts, and Associates. This is a consulting engineer. This is their one shot. This is them doing that. I would think this would all be bolts, right? But Manila took this image. This is interesting. So this is why this gauge, if you will, is so, well, this is more professional than this clown. And this is my characterization, or no slander intended, this clown image, because there's no data here. At least Manila put a friggin' tape measure down it, right? So when we look at this is Manila. This one is Manila. Remember, I did mention another video. I said that there's some grinding took place here. That means that some repair was done. And because you just don't grind after you do that. So yeah, it looks like I nailed that. Pat on my own back. But let's go to, let's look at this guy right here. So this is the part where the video cut out. Let me do it. Internet. Let me see the tractor. Photoshop. Interesting that you just said that, Hermit, because if that's their source, we don't know what's been done, if anything at all. But Manila and somebody, at least at one point, you see these lines here, guys? These lines, not this one, but this line here and this line here. These are reference lines. This is someone put it there to be able to determine. And if they didn't put it there, friggin' perfect reference lines now. This helps me determine the plane. You can see the move the up or down, etc. You have a scale here, literally in the same image. Now the angle of the camera and things like that will change just a little bit. Hopefully you got the original image. I know I'm going into photography now, but this shows your distortion that can happen if you try to be too critical with figuring this stuff out. Can you guys hear me? Great. Hold on. I've got to give me a second, guys. I got to get another. I have to get another speaker for my earpiece. I wanted to. How about now? We're having technical. YouTube. What are the odds of us and us conspiracy stuff? This is crazy. Oh, I'm back. It's crazy. YouTube is. What did we just get? Did we just get sanctioned? Oh, you heard that? Because I don't hear anything. I'm testing on my phone, and I don't hear a thing. I've got it in the background, and I don't hear. Okay, heard that. Well, I don't hear a thing on mine. Well, let me. I didn't press play. Yep, we're good. I got to turn down there. I didn't hear anything on the video because you've got to press play when you go to live feed. And you know what it's like talking to you guys and hearing my own voice in another ear. It's some craziness. Okay, I'm taking that out of my earpiece, out of there. It's starting to rack my brain a little bit. So where to leave up? So Manila is the one that handed this data over. I was at the camera. So a camera, if you tilt it, it can distort things, making it look farther away, etc. Depends on the lens and your distance, and also your angle of approach on this one. So hopefully this person was square, or maybe they just leaned down a little bit and took an image. What I'm driving at is this computer further away than that. But this is scaled. This is what makes it so awesome. There is software that can keep using this scaling. Since he did go to the center up, that you couldn't ask for a better scale than this for this image, for something that can never be duplicated again. You can rotate this scale, and if it bend on the lens distortion, you'd be able to really calculate this gap right there, even with the shadows and everything else. You'd be able to tell his lines here. You'd be able to move this down to here and figure out his lines. All right. So there's, do you see the crack? Let me get you guys, make sure I'm saying hello. That's correct, John. The cracks moved after those lines are drawn. That's correct. That's my point. They're reference lines. So someone drew these after the banner was removed. Also, you remember this guy's had, we got tons of data that we can use now. The banners were there. They stripped the banners. They at some point, then they went incognito, kicked everybody away from it. Now all of a sudden they go right into panic mode. There's the temporary support, so the structure. All right. I'm not sure if this is still the gauging equipment while doing the move. If it is, it now tells you that bolts are still there, bolts and perch. That's their equipment, I believe, or it could be the moving transportation company. Nevertheless, this is still more data that you can now say, hey, what lines are these? Who do they belong to? If they belong to Manila, it's kind of doesn't give us too much data unless they can tell us what they're used for. Back to this now. So this is what? Let me just have a little help you guys out. What's going on here? What do you guys see? You see an opening. This opening is not a compressive opening. It's not a crushing, so it's not compression. This is not compression. This is not under compression, guys. This from the top to this direction. So let's go from here. This is the bottom of 11 and 12, from here up to here. Of course, you guys know how much it really irritates me here. Everybody tell me how number 12 created compression is sliding off. Number 11 created compression is sliding off 12. You guys know how that triggered me. Well, this is further evidence it's not compressive. These are not closed. This is open. Now, I went over there, and because someone invited me over to please sign in and say hello over in that chat in the engineering group. Went over there and put a nice sentence there. I put a nice little paragraph there, and it was blown off. It's okay. But then someone, I think from that group, came and wrote a comment. You guys know I don't, I read all the comments first. And he went back down that same craziness that number 12 is in compression and pushed this there. All right. So I'm just sharing that with you that, if you don't go down that road, don't let anybody tell you this is under compression. This is not under compression. You see that? It's an opening. Now, it's going to tell you a lot more in this image. Look at this clean line. That's beautiful. We couldn't ask for another better subject. This clean line here, this chamfer. This chamfer, we know it's a certain size per the guys using tooling, 1 inch, etc. 100% we know that. So it's another beautiful scale thing that we can see how it's scaled backwards. We can move that scale down to here if you want. There's different scales you can use. And of course, we know there's the true scale. It's pretty plumb. It's a little bit out. Now, is he down to at 7 inches? Is this person down? Here's 7 right about there. 6.5. What are they butting on? What are they hitting on? What was the person that took this image? What was it? Who was it? And what was their skill set? Did they find the deepest part, and couldn't they find a hanger or something of another nature to poke down there and see the depth? You can, of course, do videos and everything else, but frankly, this is at the point where you would just want to temporarily support the structure. It's just too dangerous. Now, see, it travels up. Now, let's get out of this, and we'll come back to it. And we'll jump around a bit and make it a little more exciting jumping around anyway. We don't want to beat up each other. MCM played CIS, cover your ass. I see it pulling apart, right, Hermit? So it's pulling apart. It's not compressive. Now, let me just race through, and I say race. You guys can stop me, hopefully. Let me come over here. I don't know how. Let's see if I can do this. And these are the little guys. These are this is what I've saved over time, and you can see some dates on them. Great. That's not one of the ones we want. And let me move, see if it still keep loading to the left so I can see your comments. So we know that we've got people looking here. This is where they crack, they're looking down. This is that first post-tension cap that we see that there's some debris on top of. There's a reinforcement. There's the wood that's up there. None of it looks like little stick wood. Oh, there we go. That looks like that stick wood, perhaps, something of that nature. All right, moving on. It did allow me to push it down. Now, if you guys, so I'm just going to go, I'm going to click through them and tell you what you're looking at each one. You can always press pause later on. This is where they added after the initial inspection of the reports 2017 update. They then added another post-tension member, and I have to bring it to your attention that I didn't have this, if you recall, and I kept saying you would think they need another post-tension member here. One of my videos, my first videos, when we were looking at the 26 drawings that NTSB released to us, or that FDOT released to us. That's just bullshit. Anyway, so it was added. Now, this is the 2017. This is our 11th failure. We already know that that they should have kept the supports in while transporting. I did a video on that. This is what this is referencing. That then it's supposed to be the post-tensioning schedule, 6 and 7 longitudinal. I'll get to that because this bridge failed. You guys, let's see if I can find that video. But let me come over here first. Let me come to. Give me a second here. If you guys remember one of my videos, I said, you know, I wonder if let's do this. I wonder if they engineered it to that these are not primary, that they're kind of secondarily redundant, that the engineer, because remember, I'm thinking that this is just a small mistake at the time, not small, a major mistake, but I could not fathom that this was as basic as what it looks like when we see the cracks and all, that this is just engineering and too big to fail. No, I saw it as we just missed something so simple. And I said that maybe it was, if you guys remember, that they didn't have the other structure in, the post-tensioning wasn't pulling the two together, which would add the additional 4 cables for the top and 4 cables for the bottom, because there are 2 cables missing at the time of installation. At the time of failure, there's 2 cables not installed in here, 2 on this side, 2 on this side. At the bottom also, I believe there's 2 and 2. And that more are supposed to go through. Nope. There were 2 at the top that were supposed to go through, and this gets anchored across. That I said that let me go here. Remember, guys, I'm doing this live and working on months of memory here. So I said that that they needed that it would seem like they would want an extra one also down the center, which would be, you know, I just thought would be nice. And I have a few reasons that I could say it shouldn't be and why it should be, but they didn't have them installed. And I said that, wow, maybe those not being installed caused the deflection, caused the weakness of the canopy, which is under compression, and it couldn't take it. And then therefore it causes the failure of this intention down here. And in one of my videos, I said the canopy fails first. That's the last one I referenced in there. And I'm saying that because it wasn't fully supported. That's how I would reference that. Now, it wasn't fully supported because it was missing 4 additional post-tension members. What if they were installed? Would this bridge would take it? Well, you'd have to look at the calculations from the engineer. Did he design it that these are redundant? And now we know that that's not really a thought with these people. It's just craziness. So I had that crazy thought that, wow, maybe this was designed that the entire bottom decking with all this post-tensioning installed could take all this load, all the load, general load, not live load besides some workers, all this general load, and show no deflection. And then this comes into play as a redundancy along with the canopy. And then I really liked that. And I said, that would be awesome. And now where's the failure? You know, what happened? But it turns out that no, that was not part of the design, that this was never designed to take all this load, that this wasn't designed to take all the load. Ultimately, we don't really know the design calculations. They changed the wording on the new drawings. They changed some things, so they added wording. They added wording, and yeah, technically they would have changed it at that point, right? Because they have new meaning, new intent. So we're sliding down. This is the report, the initial report. I think this is the the Ntsb report, Bolt Perch, and this is what Bolt Perch and NTSB try to feed us at first. Remember, I said this is just bullshit, guys. They feeding us bullshit, showing us insignificant cracks, nothing to see here. But I just kept with my video saying this is just bullshit. This is not even a good cover up. And I said they should hire me. I'd know how to think like somebody like me and how to counteract this shit. Could they have worked off the wrong set of plans? Yeah, that does happen, John. The non-stamp plans, a lot of times they resurface in somebody's truck who brings them out, and then you start working on it. How do I know that? I've done that shit. You know, I'm like, where the hell did these plans come from after you're into it? And you're like, son of a bitch, and you throw the plans aside because people are mixing pages and then the stamp plans. So it's, I mean, there's hundreds of pages. You've got to really look for that stamp. And sometimes you trust the person that's handing your drawings and you're looking over it, not to have changed it. A lot of times we put them on a desk and they don't move. The plans stay there. Those are stamp plans. But some clown like myself grab the plans, takes them out to the field, hands them to somebody else, tells them to go put them back on the desk. Ultimately, they wind up in a truck. New plans come out from the truck, not the plans you have stamped. They laid on the table, and then now you have a change of plans. That does happen. You just got to fix it, man. That's just a mistake. It's just a mistake. And no, you don't tell a guy to throw away his other plans because he can use a lot of stuff off the pages. You try to find the pages you can't use and destroy those. Bolt and Perch, right. So this was that BS, that they handed us with these teeny cracks. And there's the hand of the Bolts and Perch co-conspirator. How about that? Wow, that's a tough statement. That's a tough statement. Co-conspirator to what? To building this bridge. How about that? They conspired to build this bridge. There we go. Location, trust member number 3. Trust member number 3. Nothing to see here. We're down to trust member number 3. Look over here at number 3. Don't look at number 11. Look over here at number 3. Nevertheless, though, it does have data because 3 is experiencing all its issues, as you guys remember. But look here. Just these little things going on here. That's all you got to do. Just pay attention here. And I showed you guys that his math is wrong. His type crack A at 0.007, measured at 0.04, showing he's using multiple measurements, purposely sabotaging it. That is something that how you would sabotage your thing, giving you a second bite of the apple, going, I made a mistake. Let me fix that. But this is just BS. That early crack inspection report was fraud. Some DOS says this, screening from the massive cracks that should have been the main. Yeah. I'm with you. I'm with you on that one. So this is the original plans. Original plans. These original plans. 2017. These updated plans where you show these are moved differently now, no longer on the outside. Again, this was that other engineer. We have the breaking here. Do I think it was a result of this? Let's go on from there. We'll get to it. Here are the 2 spans. This is where the 2 extra cables were placed. This would have made the canopy stronger, perhaps helped out. Would this have still been functional, moving it? Did that cause the issue? And I would say, wait a minute, let me think of this word. Fuck, no. This whole design was shit. It was all shit. You see it failing at the impound, right? That's where I'm calling it the impound. That's where it should have stated, impounded. This is never structurally sound. It had cracks as reported. After they removed the forms, you saw them covering up at that point using a whitewash. I don't know if it's Dawson said that, or I said it initially. Doesn't matter. I'm just trying to give credit to somebody who benefited, who would not benefit if it would have failed. If the moment they would have had to put the thing up, FIU would have been a laughing stock. There really wouldn't have been a laughing stock because if you could then say you've got to put a different spin on it. Hey, look, we're FIU. This was a hell of a thing we attempted. but we find it structurally unsound. Step up, eat the financial thing of it. So we need to know, then you need to do a 360 and say, now we've decided that this is now a learning experiment. And we want it, before we were temporarily supporting it. And you make it, what you do is you make it into, I think there's positive to everything. There's going to be a positive to my death. There's a positive to everything, guys. It's how you look at it. So now you say, this was the plans. Before we load test this and watch this thing fail now, we got the roads closed off. Let's go ahead and, yeah, we're going to eat it. Be the better person. Well, you can make this a positive thing too. I don't know. I'm not going to say be the better person, but I'm saying be the better the better person. I'm reading it wrong in my brain. I don't say I take the high road. I'm saying make positive out of everything. So make a positive event out of everything in your life. Hey, it's a positive to everything. I don't care what you got going on. You're looking at the negative side. Think of the positive side. You're not dead yet. If you believe that you want to live longer, you're financially broke, or you're not dead yet. You don't have to worry about your finances at the point you're financially broke, right? You're like, in for a penny, in for a pound. Well, this is what I'm talking about with this bridge. Once it's failed, it's done. It's not going in. It's not being installed. Let's stop. Let's temporarily support it. Let's close the road off. Let's invite, since we're engineering school, let's find out what went wrong here. And let's invite all the engineers from around the world. Let's give them 2 weeks to get here. Let's get this road closed off. Let's get them 2 weeks to get here. If they want to come and bring in any of their schools and do evaluation on how we're going to start load testing this. Let's find the failure. Let's go ahead and work on this, and let's see where this will not happen again. This is how this engineering has to go these days, because they're getting away from standards that worked. As you guys know, I love my bridge videos with the steel structures and the arch structures lasting 150 plus years, designed to carry horse and fucking buggies. Now they're designing these bridges to carry 80,000-pound tractor trailers lined up behind each other, and they're not designing them for that, are they? They're failing. They can't even design this to take people load. They can't even design this to take its own dead weight, its dead load. I'm saying this is not a minor engineering company. This is one of the major engineering companies of the world. This is the major engineering bridge school, if you will, of the world, bragging about it. This shit is not working. Grant money probably at a time of constraint. So it's not working. That's my rant to that. That's the sidetrack. Now, these are the oh, great. This is just the plans. These are 2016 plans. Give me a second to scroll down here, make sure they're not intermixed. These are 2016, 2017. This is what I find also, nefarious. Here's 2017. That's the bottom page, right? Here's the top page, 2016. Remember I told you about mixing plans? So why did they do this? What was their intent to do this mixing? First off, posting it, FDOT posting this, Ntsb sharing, allowing to be shared. And if it is, why not stamp all the plans again? What's going on here? So that's just nefarious to me. Well, they're cracked. And yeah, well, bolting is going to be better, cousin. I'm actually doing a lot of reading right now on welding and steel structure, bridge structures. They experience more issues than bolting, and they experience cracking, and they brittle cracking. How about that? So brittle cracking in welds. So brittle cracking and bridge welds. How about that? I got different documents I have up. I don't want to share that with you guys just yet. Fatigue cracking. Yeah, transportation research. So this is what you would look at in welded steel, and it's brittle. It's fucking dramatic. It's like this bridge. It's not easy. And my theory on that is that riveting has that little bit of play around the sides, and it can expand and contract and slide a little bit, allowing some expansion. Riveting and bolts. I'm not attacking you, man. Steel can't be repaired. Concrete can't. Oh, steel. Right. Yeah. Yeah, but I think there's some welding. They should figure out how to weld, but I don't know if I would trust it. I like the idea of bolting actually, because you make it idiot proof. They've got tools now that will take it up to a certain torque, and the bolt it pops off. The head of it, the back of it, it can no longer spin. So you'll get all the torques 100%. Well, within reason. All right, back to this. So I told you I'm gonna bounce around and make it keep it exciting and not beat you down in one direction. You guys got time to think about this? I said that. Look at this. It's not under compression. Okay, under compression, this would close, right? Under compression, this is the point where it changes direction. You'd see some failure here. Under compression, you would see failure there. Not necessarily here because the load path is this direction more so. If these two were crushing together, this coming closer than that, then you would see compression. And that said, we don't see anything, do we? But we see some major movement here. As I've always said, that the reinforcement is in conflict here. I made that video on my other channel, and I said where you load this and the rebar can buckle out and cause this bow literally pushing towards us, and it's random as you push down on the top and bottom of a reinforcement. It's random which directions you can go. You'd have to, and it's not random if it was offset a little bit. So this is, if I would put a load here and push downwards on it, it probably would bow on this side, not out here, right? So it's not, or if I had the force totally in line, maybe if it's a little bend here, it would bow here. Now, rebar is not a friggin' arrow. It's not perfectly straight and flat. So when you place the reinforcement, if you placed it off in this curvature, and this is probably a straight line, right? Because it's software. But if you imagine if you're placing rebar and it's off in the curvature just a little bit, and let's look at this arrow here, right? My line. Now imagine I'm placing it in there, and that's the line. But as I place it, I allow it to deviate just a little bit and then come back in. I'm totally exaggerating that, right? But a little bit of deviation and back in. When I load the end of the column, top and bottom, loading from the top, because this was loaded from the top, tension from the top, the forces compress downwards, and that bow, I'm calling it a bow, exaggerates. It's concrete wrapped around it, but its forces are still on it. It's creating forces on it, and this would create this bow, this break here, this crack here is what I'm thinking. This is reinforcement. Now, can it be anything else? Absolutely fucking not. Sorry, guys. Imagine it's just being all concrete and you compressed it. Well, you're going to get compressive breaks. You're going to get compression showing here. You're going to get, you're going to show the closing of it, right? As this is opening, you're going to see, oh, back to that one. Working on glass in my motorhome. I'm trying to polish it, grind it, and I'm doing all this research. I'm up to 10,000 sandpaper right now, and it's getting there. Probably to go all the way down to the bottom again. These are more than likely compressive that it's coming out. But let's scroll down, scroll up. All opening at the very, Greg, they don't show it, at the very ass end of this where it's acting like a hinge. There'll be a slight bit of compression on it. These two are crossing each other, a little bit of crumbling going on. So this is all tension. You see this opening? It's all tension, opening. You just have to figure it out. Now, the tension could be reversed. So imagine that you're compressing this. So this cap's not on there, right? You're compressing it. You're creating a ball. Okay, so a tennis ball. You guys, let me see your comments so you guys can follow this. Yeah, you can weld, certifications and all, but you're gonna that's not the failure. The failure, you got to read it. I'm still reading a lot of reports on it. The failure is more so it's probably two dissimilar metals, your welding rod and how your materials are made, and then you're heating it at that point. You're creating another an unknown factor, and I would say unknown because today I weld a little slower. Tomorrow at the different heat, tomorrow I weld faster. You're heat sinking your metals differently. And so I think that would be a major Yeah, I'm working. I'm doing videos on it, Jeff. It's a motor. It's got acid. It's where it's not acid. I don't know what it is. I guess this would be it's a long ass video. I'm still, once I figure it out, I'll show you. I'm almost there. I've got it. I've got all the spots removed, and I've got about 15 hours into it. The spots are moved off the glass where people are replacing their RV windows for hundreds of dollars. But I've got to get down. I got it down now to 2 hours. But I'm not fully there yet. It's not acceptable to me. So, all right, back to this post-tensioning. I'm trying to figure out how this was created. It didn't get around this reinforcement, did it? This reinforcement didn't create it. There's no crack off this reinforcement. Is there other reinforcement here? Probably not, because of the cover is so minimum. So this is not like a compressing and then reinforcement going on. So this is what I theorize on this one. This one's I'm still going to sleep on it some more. This is the post-tensioning, right? This is the end of it. Now let's go to a real image. Give me a second here. Real image would be down here. Here. It's like playing a game of cards where you got to find out where that last card was. And so I got to reference my brain that way. So this is that one. This guy is this one. See the cover here, this distance here. And now let's move this over. Let's move this one over here. There's the upright, number 12. There's a transition in colors right here, coming down. There's a crack. I'm going to call that a crack. And I can't reference it as far as this is that stuff. I know it's below this rebar. So there's a pigtail rebar there. This is above. See the cover? So the pigtail rebar is here and here. So this rebar is this one. This pigtail is here. See the cover now? If I can enlarge it, you guys, it's a little bit of cover from here to here. This is just indication of rebar conflicts, also movement. So this crack, I believe, is from this reinforcement. Why did it move so much? Let's think about that. It's at this point the bridge is failing. It's moving. This could be under tension. This could just be dragging, pulling. If it's falling down, though, see how if your bridge is falling in the center here, then this is creating this under tension. You're actually pulling it inwards, right? This is an outward force, not inward. So let's go with this now. We got this post-tension cap. Let's remove it. Now you got your post-tension system in here. As you're post-tensioning it, imagine a tennis ball. Now you got a tennis ball. Push a balloon. Let's go with a balloon. As you push your finger into the balloon, that's what this would be doing, pushing it in, if you will. As you push your finger into the balloon, the outside of the balloon starts pushing outwards, right? Back to around your finger. Around your finger. So I'm thinking this is a force similar to that. This is pushing in, this force is pushing out. That this is all a conflict of materials, metals. This is a strange duck here. All right, but that's that one. Let's move on from that. That's my first grab at it, and I need more. It would be nice to find the detail on that reinforcing detail. Then I could probably nail it down even better. But right now, I've got it nailed down to this is that reinforcement. That's the cover. That's the other reinforcement. We've got a break here, and this does not look like a compressive break. It looks like, again, more like a tension break. Separating. Remember, compressing is going to look like crumbling material is going to be forced against each other, right? I'd love to see the crack measurement on that. I think this is an opening, and you can realize what that would mean. That would imply that this guy's already feeling a moment coming downwards here, and this is already starting its failure. And this is one of the first indicators of it pulling apart. No longer in this is a dead. So in design, this would just be like a zero force pretty much. But minus is very important. It's not a zero force doesn't mean anything. But the forces are coming down here in design, apparently in design in this structure. But this is still under, the loads on this are compressive. There are a huge amount of load still. This part of the canopy coming down there, along with this. How do you get an opening tension opening if it's so much load on the compression. Well, it's got to be pulling apart, right? As the name implies. Okay, so you have to look at this more. You'd have to look at it more, and you want to see inside here. You know, inside here. This is where all that gamma testing and everything else will take place. But this is also pretty damn hollow, isn't it? It's got the pipes and tubes and all this stuff running into it. So it's not really designed to take that much load, as you guys recall. Now we'll show its failure later, but keep note of that crack, because remember we have the failure that's sitting on the pier. So let me see if I got any comments you guys want to chat up about. But keep note of that crack. Okay. Okay, thanks, John. And we'll this picture was taken here, and John is saying that this picture was taken on the side of the road. John is saying this was taken on the side of the road. We have this is March 14th, John. Top of deck, looking down view of the crack. Timestamp, March 14th, 1:50 p.m. Labels added by Ntsb. So, John, do you see we got the March 14th? Great. I thought I was so happy to click to the right there. Wait a minute. No thanks. March 15th. That was John. So it was already installed. It was installed on the what? The 10th? The 10th? What day was it installed on? You guys got that handy? Was it the 10th? You guys got that handy? I don't want to give wrong data. So you can see. Oh. Hey, John. No, man. No big deal. No, it was good you did it, because someone else might have thought that. We're addressing it now. So, and I got to verify it. I could have been wrong. You know, I'm doing this on the fly again. I've only had it as long as you. You could have been right, John. Or, you know, your question could have been right. But really, I'm doing this on the fly. I only made it so far in my sleep. You're looking at sleep work now. I really do work in my sleep. So there's the image. We already did that one. And this, I think, is a duplicate. It doesn't matter anyway. I've got a video on. This one's odd. I think I lost all the files here. I've got this title, and there's nothing loading. Oh, no, I guess I thought it was a recall in my brain. I thought I'd lost it. Same thing I did again. This was what I originally went really into. That drove me crazy. There's a secondary fall here. I didn't share this as a video online. This is just me. You're seeing inside my mind with some of my videos before I produce them. Now, this was driving me crazy, taking on data. Now we've got the, let me pause it. I did it paused. I'm pausing inside this one, right? Yeah, I can do that. So see, you can see the MOV file. So you already have the deflection going on here. And this is why I'm saying 10 failed first, because it's under compression, right? The loads would be transferring down here if number 11 was under compression. We'd see buckling. Initially, we thought buckling. Initially, I only saw that, oh, that's going to be great. I should actually reverse this and go to my first bottom video to show you how I saw it on Twitter, basically. And I was going at it with another structural engineer over there. With a few of them, we were all going at it. And here's Denny Pate. We got to hear this. I might have to fix the mic on it. Tell me, guys, if I got to fix the mic. Yeah, that's a software that protects me from people listening in. We got to hear this. I might have to fix the mic on it. Tell me, guys, if I got to fix the mic. That's not possible. That's going to be backfeed. Going to be backfeed. Let me see if it won't. That's going to backfeed. I think. Let's try it. Nope, no luck. Now I got to check to make sure you guys can hear me. Oh. Now, if you guys remember that this, oh, these are just stills. This is a video. Here's your spalling. There's some compressive action going. This is lower than that one, apparently. It's the craftsmanship we talked about. Let's move away from that. That's not, I've already got videos on that. Okay, these are videos. And these are videos I didn't load for you guys. These are just trying to get data to share and merge videos. But here's some images. So this is an image that we have. So now we're doing it live, and you guys see all of my data snatched as I can snatch it. So we've got some data here. There's them with the banner on. A ladder was on there at the time. There's this. This guy goes down to there. Oh, I can't. Now we know exactly where to look. There's a tree in the background for reference. I don't know if this was in the impound or not. And this stuff could just be, like my man said, Photoshopped, whatever. I don't trust any of that data anymore. All right, this is where I said pay attention to that crack. We have that crack. There's the piping. There's some spalling, some movement of material coming off. There is the failure. There's a J-hook in here of the rebar showing that it was basically just going along for the ride. Let's see if we can do something else. This is what I thought was the MTM guy. I don't know if I said this to you guys. I think this is the bolts and perch. This is professional equipment. I don't know if they did this marketing or not, but you've got a separate mic, you've got a cordless mic, and you've got this guy who appears to be a contractor too, not actually a camera crew member. So we've got video that we would like to capture from here too. Apparently they know how to support the structure too, so that's not like they can't support the structure. And update, let's see what FIU Bridge project. If you please visit, I tried to find this, that wasn't possible. Here are the reinforcement that everyone says that causes issue. Let me look at my phone to see what you guys got for me. Thanks, Herman. Yeah, I saw that, Herman. I saw that part. This is all this is supposed to be under compression. And now remember, I'm saying that currently, I'm saying that the loads went down 10, that this was not under compression, that this design, and I thought about it last night, that what happens if this was longer, this member when you're building it, was longer than this member, number 10, that this is no longer in plane. Say that this has to be 100% from here. Watch this. Let me do this for you guys. From here to here, let's just round the 10-foot even, right? This is not the size. And from here, let's change it to 10-foot even. Here, let's change it from 10-foot 2 inches. 10-foot 2 inches. That puts a bow in the bridge there, right? Camber at the top, and I'm going to call the bow the bottom like this, and I'm calling this a camber, right? That's what you guys can relate to. So this puts a bow in it. So as the loads try to work their way over, it's got to go down the bow and back up. I'm just finding another mechanism of failure, guys. That's all. This would be very critical. And so it would have to go down the bow and back up, creating a path. But that actually could help you if it was deflected down, say 2 inches, because the post-tensioning would be a counterforce pushing upwards, pushing more force up in 10. This is major, this 10, this whole thing here. The whole failure is from this section here, all this guy right here. This is where your failure is, but it also could have a lot to do with spacing. If the spacing wasn't 100%, I would love to see the as-built and know 100% this and 100% also I'll show you an image of it. The profile of the post-tensioning here. Was it going up? Now, was it going down? So now the post-tensioning, say the post-tensioning rod goes this way, right? The bars, cables go this way, and all of a sudden here, instead of being flat, if you will, we're going down and back up. What happens if you deflect it by mistake going up and then back down and then coming across? Now when you post tension, you create a force downwards right there, because that's how critical post tensioning is, guys. It's not made up. This one's not made up for you. It's not a theory. That's how fucking critical it is. If you get a string and you put a string on in right hand and left hand, use your cell phone cable, and right hand and left hand. Now put your chin on the, pull it straight. Now put your chin on the center of the string, and now that's your post tensioning with your right hand and left hand. Now pull the right hand, left hand taut, and you'll see your chin will rise. Now resist that forces with your chin and pull, and now that's your post tensioning now, if you will. Now that you see the forces are doing what on the post tensioning is pushing upwards towards trying to lift your head up. Now, if I was to do that here, and now it was cambered up and back down, the forces would be designed to push it downwards. I'm looking for the failure here. I'm looking for forces to come down to transfer the 10 and transferring off of 11, because just think about this. Let me look at your comments. It broke at the end, the highest vertical member. I can't be so confident like you. I can take data and then make evaluations, but I'm still taking data. Because in design, let's go back to this. Now let's not slander or beat up, or not slander. Let's not beat up. My intention is not to beat up Danny Pate now. Let's just say, let's work on the assumption we can make this work. So these are all evenly spaced, perpendicular to each other, parallel, and whatever they're supposed to be, right? That this is as designed. Well, if it is as designed, and two engineers and multiple engineers looked at this, but two for sure, Danny Pate and the other consulting engineer, looked at this and said, hey, this shit will work. You know, that's them. And also, let's say FIU did a unofficial look at it and said, hey, this shit will work. Well, if this shit will work, why didn't loads go down number 11? Why didn't they go down number 11? And why do I keep saying they didn't go down 11? Because we're looking at the images here, and I guess I should have went the other way. They're not going down 11. It's something else going on here. This is not even, at this point, this is not participating, right? You have to realize this is not participating. This is just junk, and we know it's not participating. There's no compression. There's no load on it. Yet there's traffic going on underneath this bridge at this time. That might be a wrong assumption. They might have taken this before they opened the road up, which would be even fucking worse, right? But they're saying, no, that's right. We got a timestamp. March 13th. Hey guys, help me out. When did they open the bridge? We get a timestamp here. When did they open the bridge to traffic? FIU. That's another data. I'm loving this now. Now you guys seeing where I'm going with this. And I said it was live chat, and I said it was communication. FIU bridge collapse. When did they open bridge to traffic? You guys help me out here. Hermit was usually pretty damn good, but I pissed him off, and now he's no longer sourcing me. Hey, Nuclear, how you doing? No, John, the post tensioning didn't destroy it yet. I'm saying did not destroy it. Oh, I'm sorry. Correction. It participated. If the rebar reinforcement theory I come up was true. Come on, Hermit, get back on it, man. Where's my when did they open the bridge to traffic? And we're going to reference that image, that photograph. I March 10th, got it, apparently. FIU bragging about it, 11:38. I find time so interesting. 11, they like to 11 o'clock. Okay, 11:18, March 10th. One more time at that. I think my brain just froze up. I thought I found this thing to be 175 feet. Didn't I find any other plans to be 175? And I call it 174. It's kind of pissing me off that FIU and F dot, everybody keeps calling it this, and I think it's 170. Oh, no, it was 11, the span distance. Yeah, everybody's saying it's 11. It was 12 foot. Nah, that's just childish for me. Let me move on. It's just something else that they don't, in the quality work, comments. It's not childish. It's just anal because it all adds up. The extension. Look at your comments. Research when the things are dragging. What the hell is it? When did they open it? So we're back to this one again. Let's take this one again. 11/18, March 13th. So it was open. It failed 2 days later. So this bridge is functional at that point. Traffic is going underneath of it. Let's confirm that. I need to confirm the confirmation when they opened it. They opened it that day, didn't they? Damn it. I did not see this in my mind. Mario Diaz Bolton, he has to go get researched on how much money he might not have taken. U.S. Representative, Chairman of the House of Appropriation Subcommittee of Transportation. Wait, he's the one that started the event? That's something else. We don't have to go down there. Tiger Grant, blah, blah, blah. This was all proudly about it. He was proud as shit of representing that. All right, when did they open? Opening of FIU Bridge. Me too, but I'm trying to get confirmation on that, John. We saw traffic, but when did we see the traffic? I want to relate what I'm driving at, so you guys know where I'm going with it. I want to relate to when that fucking traffic was open exactly to when this image was taken. The point being is that, was this taken after traffic was allowed or before traffic was allowed? That's significant, isn't it? And let's find that. Let's say that it was taken after traffic was allowed. Then they evaluate, okay. But before traffic was allowed, that's even more craziness going on. Either way, it's shit, but they're killing me here. I hope you guys are trying to find it too. Let me just jet this forward. So right here, we see traffic going in. Some workers on the bridge real quickly. Back up. There's a crane there. There's a worker on the bridge. There's a crane on the other side. Can I scrub this? Nope. Yeah, I can down the bottom right corner. Oh, top too. The place XXX will come. I'm not sure what you mean by that. $5 hours using ABCs. When did the fucking bridge open? How the hell they backdate that? Am I reading this backdated? They're talking about the cracks before the bridge failed. March 12th. Somebody backdated. Man, these people are so damn awesome sometimes. These damn. Monday, March 12th at 5 a.m. Is that what you're thinking? Let me see this. Some people know how to backdate stuff. March 12th, 1:15. The bridge is not collapsed yet. And this person's. No, they hijacked my FIU bridge. Yeah, they hijacked the statement. Yeah, that's all they did there. That's nasty. Some people do that. See the Miami FIU pedestrian bridge had cracks before collapse. They title it this way and then they hijack it so you can run there and get seen by it. I just like shit like that. Google that would be like fake news. Closures and detours. FIU pedestrian bridge closures and detours. March 10th. So Channel 6 does this a lot. I've seen this a few times in my research. I've seen them do this same shit I'm just talking about. So here's the real article, and this is how they titled it. FI causes closures and detours. There we go. Maybe I read that wrong. Let me give it a second. Maybe I got too excited. But they do that. Somebody said 5 a.m. Can you get me that? 5 a.m.? It matters on that one thing. West Miami, Florida. Monday at 5 a.m. Here we go. The portion of the street will be closed from 9 p.m. March 9th until, reading your comments, 5 a.m. Monday, March 12th. Friday, March 12th, right? 5 a.m. So that's the 12th. So if we just consider it opened on the 12th period, the next day on the 13th, 24 hours and some change later, they're up there 11 o'clock. Incidentally, they took 11 to 11:18 to document it. Let's say these crews start 7 a.m. They took 4 hours to document this. Let's say this did not show up 24 hours before. So this is where all this data is coming out. This crack appeared within 24 hours then. I'm saying that because if you're going to open at 5 a.m. on Monday, and that would be the date of the 12th, as somebody just verified for me, the next day, 24 hours later, you're looking at this. Clearly, you didn't open a bridge. I mean, clearly, you should not have opened the bridge with this present. So in 24 hours, this appeared. This shows no compression going down number 11 in 24 hours, that this thing is loaded. Now, they knew this in the impound. Again, I call it the impound, that they did some repairs. We knew about with the whitewash stuff, things like that. Let's move on. Now we got that data figured out. That's very interesting. This one's 24 hours later, no compression. So if you guys got any questions about why, you can see this is not taking a load. This is not kicking off jack shit. It's not moving number 12 out of the way. It's not under compression. And that's where I'm saying that the loads are transferred down number 10. And from 10, the loads have got to make their way over to the pier. They've got to do that by using the canopy and the bottom deck. This would be the top deck, bottom deck, canopy, because it's shaped like a canopy. I called it an umbrella at one point. The canopy and deck. So they're making it over there through the post-tensioning, the reinforcement they have to the cable, and the little bit of resistance that you can say the concrete can add, which is nil. Nil for a structure like this, in my opinion. It's negatable. Yeah. So now we have the loads making it over. They're not making, and so this is the major point I'm making, guys. It is not making it down 11. There is nothing going down 11. This design right there would tell you this is how I could evaluate it that quickly. If I had that image, I go, oh, they had a 2-hour meeting. I evaluated talking to you guys live and telling you live, and it's not 2 hours and bullshitting around and cursing and everything else. And where we go here? Where the hell you go? Looking at this crack, I can just tell you immediately it's not under compression. If this isn't under compression, that means that load path is not going down here. And I am clearly sure that the load path was designed to go down number 11. And once we see that there's not compressive cracks, shit, the load's not going down there, man. The loads aren't going down there. I'm fucking panicking. Stop the cars. Let's evaluate this longer. This thing needs to be shored up. This whole design's failing. It's opening in the fucking middle. It's failing in the middle. It's failing in the middle there. But this is staying together. This tensioning is still staying together. It's failing by dead load. And that crack was this guy, I think, post-tensioning. So for clarity, this came from the dream. So this is the top part, right? And there's the bottom part. Take a look what we're looking at. We're looking at the top, guys. If you recall, they showed it, the NTSB showed us images of the bottom crack. And that's what I kept telling you guys, where I said, look, imagine you loaded the top. I did a whole friggin' video on it. If I had more data, I feel like I wasted my life a little bit. So if I had more data like this, it just makes it so much easier to get my conclusions. So this was post-tension first. As you guys remember, they finished post-tensioning this one. They were working on this one. At one point, I did get some data, guys. So I'm going to try to tell. I got some data from somebody who shared with me. Now, the data is not what you think I got. I didn't get technical details. I didn't get that. So the details I'm giving you, don't, because I think someone might have thought when I made a comment to me in the past video that I have some technical details on this. I did not get those. I got other details, but none of it was technical. Let me think about it. None of it was technical directly, that's for sure. It was more about negligence is what it was about, and about them being negligent. So I can be clear about that. I spoke to the person again. They gave me some nice, little more range after looking at my video. So that's the clarity on that. So, but if you guys remember, I said that they first did the other two, then they came down here. I'm only working with the data I have. I'm real pissed off that, that I didn't have this data. I said this number was done, then they worked on this one. So this one was completed, then they moved over to here. I said that this created a load at the top of this number 11, which created a force at the bottom of this, creating tension at the bottom, which could help cause this to fail at the bottom side of this, because I'm assuming that the top is completed perfectly, and they see no indication besides those small cracks that we were released by NTSB, showing this fucking hairline bullshit cracks that they showed, not this, but that other stuff. I don't want to move away from here. So I'm talking to you guys, sharing all this crap, but reality, as these crews up here, this negligent crews are up here, these fucking VSL, along with everybody else, they're up here doing this, guys. They're working on this shit. They are working on this. This is not hidden from them. This is available to them. Now, I said I didn't get the data like this. I didn't get this. I can't tell you exactly what I got. I didn't get this at all, or I would have alluded to you guys in a video. So this is fucking bullshit. What do you hope to accomplish? So now I'd like to give you something. Let me think about it. Look at your comments as I'm thinking about it. Reading your comments. Okay, so John says they tension the top one. This is the top one here, John. I'm reading your comments on my cell phone. Looking. Over tension, snapped. Look, get away from the snap part. It didn't snap. I don't think that I don't have data on that, but I do have data on it. It didn't fail. It didn't fail by them over tensioning. Let's look at the NTSB report. They said they did testing on the subject member, and it passed. For the snap, it would have been past its loads, its ability to perform, right? And it would have no longer been able to take it, and it would have broke brutally. I don't know if I should tell you guys about plastic and all that, getting away from the scale. You know, it's a scale that goes up. It can deform. Here's a scale. Here's X and Y, right? It goes up, and it can rebound, up, rebound, up, rebound. Materials can do that. Some materials can only go up, never come down. This reinforcement, the post-tension bar can go up, and imagine the scale coming up like this. And as you take the load off, it can come back, right? At some point, you pull it past its point, it can no longer come back. And it actually gets stronger for a while there. Now it balances this way and getting stronger. It's stronger, and then all of a sudden it just fails. There's no coming back. If you stop here, tensioning at this point, it will not come back to here. So the NTSB, I'm saying that their statement is saying that these things passed muster. So that means they were still plastic. So this plastic and metal. Cool. I like this one behind the cage. Is probably more of the true video. You've usually protected. So let's see. I'm not no volume, but you guys can look this up. Let's see if I can scrub it. So there's your member going. He's testing a flat bar, checking the thicknesses. This is sort of what the lab would have done with the NTSB stuff. Going to measure thickness, right? Put the thicknesses in. He's going to put it in here. He's going to pre-strain it. It's a grab here and a grab here. Let me see. They tested the design specs, but happened on the day was overtension post specs. Now they had the material. They tested the bar. The NTSB tested the little bar, so you can test it. So now this is. Let's see if he's going to show the strain curve. Is it here? Let's see if they show it. Let's get you. Come on, show a curve. I guess I picked the wrong horse. Let's see if this one got the same people. So there it is, stretching, coming back. Let's see if they actually rebounds it. Oh, looked already deformed, didn't it? So he's stretching his guy, creating. That's going to test it for width thicknesses. Okay, here we go. So it goes up, and it can come back, up and back, up and back. At some point, it's going to go level off. It's going to actually get stronger and then break. Most materials. Let's see what this one does. And it broke. Come on, I'll show it. Come on, show your graph. There we go. I guess the peak strength is here. And then, well, this one actually, being plastic, actually stuck with it for a while and then broke. I don't know where it broke. Here, maybe there's a little crumbs holding on to plastic. Interesting. That was interesting. Come on. What's this? I just want to show it to you guys real quickly so you can understand the post-tension rod, why it didn't snap. That's a real live load. This is going to be nice. This has got a nice craft to it. So watch this. Didn't they compare it to the other piece found in the rubble? The rubble, and they had another piece, Rat, that I said is ambiguous. That they're saying they say from the site. Let's see, some damn wording pisses me off. From the site. It doesn't say it's from the protected. You know, it's ambiguous. So what the hell? Where does that piece come from exactly? Here and here. Okay, so he marks the measurements. He's going to be able to check the elongation on it. This is how they would have done that rod, similar to this. He's got a tool he's going to use for either separation or checking it for strain on each side. Let's see that tool open up. This one. Yeah, on each side. There we go. And always going to show the graph at the same time. Beautiful. So now this is grabbed here, and it's going to start elongating it. And it's an 8-minute test, so I'll scrub for you guys a little bit. And there it is. It's elongating. It's still got strength. It can still rebound. Right now, it's still in the rebound stage. It's straight up and down. If he lets go, up there we go. If he lets go here, it would have come back. But now you see it. It's dropped down. It's going to stay in strength. It's going to fail. Hold on. Let's watch this thing fail. See, it's still picking up strength. This one dropped down on here. Still picking up strength. Still got strength. Here we go. It actually peaked now. See, it peaked above this, dropped down, had a little funny little thing going on with this material at 32, but now we're above 32. It actually got stronger, but at some point, it's going to this way you will get your snap. People say snap. Let's watch it. It's at 34. This thing is kicking ass. Right here is where it could have recovered. Now it's just chop it off. You know, if you were pulling on this cable, you would have longer material that you would have to just remove. But it's not performing as it should though. 36. Look at this thing go. Shit. It's gonna just pop. When it pops, guys. So you would be able to test it. Now let's go with this. So who I'm talking to here, Rhett, and everybody else. I'll stop this for a second and get back to it. So you have a known bar. You know what it can do, like this test here. And now you take the failed bar, the one in number 11. You take a section of it, a piece of it, like this, and because the whole bar is going to experience the same thing except for at the ends. So the well, I can't say that because you'll see this break around here. So obviously the experience more in the center, which is my thinking. So now you take this bar, you check it for width. Now, if the bar, as this is elongating, this bar is getting narrower, right? It's getting narrower. So you then have some knowns. You grab a new bar, and it's been part of this sample, a sample bar that you knew it was supposed to be protected in a cage, if you will. You then have your current bar that you knew that you have on the failed structure. You check it for width. If they come out to the same, that bar released its load, and it came same, right? I love that, same, you know, you're teasing, right? So the bar was still obviously good, was recovering. This bar will never recover to its same thickness again. You have the entire bar to check now. It didn't disappear. It's on the ground. You literally, remember I said I would take apart this thing right there on the ground. Roads would be closed. We'd take apart all that concrete piece by piece, and you'd get to the bar without ever distorting the bar as you take apart the concrete from around it. Like you're doing, looking for damn dinosaurs. Now you take it apart and you run across the bar, and then you say, here's the bar. And now as you're on the bar, totally exposed, right, guys? Piece by piece, like you're exposing a dinosaur. I'm going to take a drink now. And you'd measure the thickness. If the bar comes out perfectly same thickness as an untouched bar, you know this bar did not pop. And this is the theory of the pop bar, right? And I'm talking to Depont and anybody else knows it. There is no fucking pop bar if this thing is the same thickness, because you're going to see when this pops, you're going to see what happens. I'm sure they're going to show it. I feel confident. Let's see. Now, this guy is a professional expert on this stuff. So we're going to use his terminology. It's a neck creating. The neck is it's never going to come back. Once this neck is created, if he was to stop his test now, this neck is there. It's beyond its plastic ability. But now it's topped off. Remember I said it's going to plateau? It appears we're plateaued at around 36 and some change. And here's the drop off. And wow, this bar has got some, it's got some strength still left in it. Look. Oh, I thought I paused it. Pause it now. There's the break. Here's the break. We slide over at 22 kilonewtons. This thing is going to break. So it's serviceable 22 period. You can stretch it, pull on it, everything you want. You're going to get 22 kilonewtons out of this thing until it breaks, if you follow that. We have 4 bars to fail, guys. Remember, there's not just one. Everybody says they heard a pop. Well, yeah, maybe they overloaded one, but you get to test every single one of them. They're never coming back. This is what your pop would look like, your elongation. You're going to have some deformity at your pop, at your break, or you're not. You know, as if imagine if you grab a pencil and you pull it apart. Well, not a pencil. That was terrible. It's not going to pull apart like that. Anyway, you see what's going on here. You're going to get this elongation. Did you see when it popped? Did you see this thing shrink back down? Hell no. Or, you know, like cursing now, right? Hell no. It didn't shrink back. Let's go to 359. This is what it started off with. See the spacing there? This spacing is now this. Oh, that was perfect. Oh, hell. I like this guy's video. Broken, there's your elongation. So this is how you can determine about the bar, guys. So take care, John, if I already missed you. Yeah, John, cheers. So this is what your elongation would look like. I hope that term helps you guys on this pop theory, on elongation and all that. All right, so back to this. They post-tension this. It's fucking out of mind. That's negligent. That's negligence. I mean, that's you really. You're an expert post-tensioning company. VSL is an expert post-tensioning company for doing repairs, guys. I hire them. Let's say I hire them. You know, theoretically, I hire them. I see this in my. Hey, put some close that up for me. Put some post. Yeah, I tell them to close that up for me. Put some post-tensioning that. Close it up. Now look where the member's going. It's diagonal. It's going. I'm sorry. It's in plane with this, right? How is that going to close that up? All it does is create more force on number 11. So this is what I'm thinking. And this, you guys are getting it live now. I'm thinking Denny Pate was using post-tensioning to force the forces down number 11 from number 10. To force them over down there. And so this is, to grab it and force it down. So to try to use this to force it over to here. Using this is like a little fulcrum up and over like this. Imagine this is a pylon up here. Okay, I think I can visualize this for you guys. Give me a second. I got two bridges in mind. Cable stay bridge. What I have in mind. And let me just grab a fast one that will show you. That's probably the best one, whatever this is. Temporary cable. Okay. I wish he had a little more squared up with this. My settings didn't like that. Okay, we'll just use this. Imagine this path, right? So, kind of like what they sent. There we go. That's even better. See how this comes up and over? See these little tubes and all that? They come up and over, right? Up and over, up and over. Imagine this. So if I was to pull down on this one, it's going to pull on this one, lifting this one up, right? The forces, these two are tied together. One to the other side. One to the other side. Right? Pulling down on one, all this might be an anchor. Hell if I know. It should go all the way through. But it shouldn't be an anchor. You know, I'm not going to just tell them. Well, I'm not going to tell you exactly what you're looking at. The hell I know. I can't see it. So imagine if this was a tower here, put a tower right here, and I pulled on this one, it would pull around, lifting this one up and putting the forces back down here into here as an anchor. Was that his intention, Denny Pate's intention, by adding post-tension to this, that it would force the load off of here, off of 10, back up around this node, if you can call it that now, and down here and pulling it back around here, forcing the loads back down 10. That's why you need Denny Pate to get immunity, guys. That was kind of an odd thinking. I don't think it would happen. I think you're just forcing the forces down again and creating more forces at the top. I would think if you would have in that thinking I just said, if you would have put post-tension ish, you're creating forces here and here, but you're just, depends on this angle, you're putting more forces downward, which is more on 10 again. I think he was somehow trying to recapture forces in 10 and 11 to go down 11, you know, so the load, I mean, I just can't imagine. Believe me, guys, I deal with a lot of people, a lot of engineers don't do structural stuff. A lot of civil engineers don't do structural, and they just don't get load paths. You think everyone would, right? It's like a doctor being a doctor. Do you know a doctor can do brain surgery on you? Any medical doctor can do brain surgery on you. It's not illegal. They can do, so you can see the extent of that. They can do heart surgery on you and everything. They're not qualified, you would think, right? But they can do it. So, you know, these engineers, you can do almost anything you want. You know, that's why they like to have formulas and things like that. You can't even evaluate this in 2 hours, guys. This would be an impossibility besides me saying that, ooh, it's not taking load. There's no way this is taking, if we know what's left here, let's call it 4 inches, and we know that the bridge is designed, and I calculated this to say, take 375,000 tons of load. And I know that on an angle of whatever this angle is, that 4 inches can't take 375,000 tons. I can deduct that, oh, fuck, where are these loads going now? These loads the bridge is not collapsed yet. So these loads have to be transferring into the canopy. These loads have to be transferring into the canopy, into the deck, and down this number 12 to make it to the pier. And then you now quickly start freaking out, going, wait a minute, can this take those loads? Can my post-tension take those loads, transferring them over there? Now, don't forget this, guys. This is a concentrated load. This is not an even load. This canopy is a canopy. Looks like this, right? Canopies. And it's got a post down the center, if you will. These are posts. And each one of these posts have a contact point down the center of this deck. If you can imagine a profile. We look at this and we imagine it's fully there, but this is what, an 16-foot wide canopy trying to transfer its loads down. Each one of these posts being what, 2 foot wide, 1'9", something like that. And then, so here we're getting point loads in the center of the deck on this post tensioning. Coming to here, we have this. And I said post tensioning coming to all the loads are coming to the center. And I'm going to help explain this a little more. Where are you? How would it transfer 11 to 10 without a pivot point to transfer it? All right, give me a second. I got to take another hit of my drink. All right, I had to do that for fun, guys. I got to hear that myself. I'll answer your question. All right, let's get a side profile of this. I want to keep this image somehow, though. I'm going to screenshot this image. That way it's in my another folder. And his question. All right, let's do this. So who are we talking to here? Two-stroke Prince. So two-stroke Prince. So our loads to this entire canopy, 16 foot wide. Here's C2. This is open. Remember, there's no post tensioning in these guys yet. This one, this one, this one, this one. This was a previous video I did way in the beginning when I was working on the data. Here is the loads of this entire canopy. Where do you think they're making it all out here? And they're magically making it over to this column somehow? They're transferring down these columns. Consider them columns, right? The truss members, whatever, but consider them columns. It makes it easy for me to communicate with you. So here's a column, because I think of them as columns, and I think of it as, so what's the load it can take, and then what will it buckle? What's this compressive load, and then what's this buckling load? That's what I think of them as columns. And then then of course the hinge, I mean the truss plate. This would be all truss plate inside here. And when I say inside there, that would be truss plate. That didn't work. Great. This should be like a truss plate. So as we're looking at the underside of it, we're seeing that archway, the arched curve, the umbrella, the arched canopy. This is a truss plate. This would be a truss plate, truss plate. And focusing again on how would it transfer 11 to 10, pivot point to transfer. All right, let's just work with this. It's kind of simple two-stroke. If I remove this all the way two-stroke, where do the loads go? By default, they have to go down this. They'll go partly will be on this canopy, and partly on the it will be on 10, and also partly on the bottom of on the deck, transferring over here. That's if I remove this 100%. Do you have that so far, two-stroke? I need to see a comment on that. If you understand me just removing this. And then I'll show you how I'll remove it. Guess my comments aren't reloading. Oh. Yeah. It's all integrated. It's all integral concrete except for the voids between the post tensioning. These aren't grouted yet, as far as I understand. So no, it won't just be solid. I mean, if these aren't solid filled, then we have contact points using a straw. You have a straw, right? So on each end of the straw, I put a little bit of concrete on the end of a straw and the end of a straw. Imagine that, right? And you compress, and then I compress it. Well, the straw is hollow, right? So it's going to fail sooner than if I fill it solid with concrete. Now imagine I fill it solid with concrete now, a straw. My straw is any size you want it to be. Now you can see now I also have the compressive forces of the concrete working against me and the confinement of the straw outer walls, the tube to keep it from moving to help me. These, as I understand, were not solid grouted at this point. And if they ever were, I don't know. It's going to be. They're in tubes. So, no, they're not solid grouted. These are 100% not solid grouted, and I can show you that. And I'll, you know what? Let's just cut to the chase here in a minute. Let me write my notes for that straw. Not the straw, but the, I'm going to show you that, let me write my notes. Show no grout, no load. Trying to think of another word. If you guys remember the post-tensioning, and I wrote my notes in that, it always bothered me that there were no tearing on, give me a second, on the post-tension tubes. So it always bothered me that this, I can't get to it yet. All right, so first off, let's hit your point. Two-stroke, good. I was concentrated to the roof at 10 and 11, yeah. So if it's concentrated to the roof at 10 and 11, this is the opposite end bridge. But I'm just using this. If we're here now, this is 10, let's call this 10, let's call this 11, right? It is not 10 and 11, so nobody trolled me on that. So if we're, if this is 10 and number 11's out, well, then all the load's going down 10. You can see that. I'm guessing you could see that. What I got here. This is an old image I had, and I say old, it's an old one. So let's see, 8x10 steel plates, right? Cantilever, A-point load. And obviously, this is doing transportation. I was making comments about the loads, and that is in another video. It doesn't help us with our communication that we're trying to work out now. I'm gonna get to you. Let me do this. So this apparently is 10, and that's 11. How do we know what we're looking for? I just wanted to see if there was any data. I know where I'm going with it. Give me a second. So this, I don't know if this is the day of the move or not. It's kind of weird. I think they had a dry run of this damn thing. That's what I recall, some dry run. Right here. So I'm talking to two-stroke. Okay, two-stroke. And everyone else. This is what I found fascinating. That remember I said it ripped through there, showing the ripped through there, creating. That's the only thing I could think of that I've never seen. I said, I think I even said in the video, and I don't know if I edited it out or not. I said, wow, this would help us explain what it looks like. I was kind of excited about it. What it looks like when a post-tension rod rips through the bottom of a column, if you will. And I said, I've never seen concrete rip like that. You know, I've never seen concrete rip at all. You know, you never, I can't think of how to, I can think of how you would do it, but I can't think of how it would happen. You know, at that point, it wouldn't really matter. But I said, it was interesting. And I said, it's like it tore it out. I found it very amazing. And I'm going to show you that. But what I found really amazing about it, though, was that it ripped it out and it didn't damage this plastic, not even deforming it. This is the part that really fucked me up. But I still went ahead and said it ripped it out because I didn't have that other image. And I was like, I just find it amazing. So I'm saying, data-wise, you know, my future crack analysis and everything, okay, this does not mean that this didn't suffer or take on an event that was traumatic, that ripped itself out of concrete. And even though it's so perfectly round here, now I'm showing you that it's so perfectly non-deformed. I'm like, fuck, I'm like, wow, somehow this can do it, you know, because I'm looking at it. So somehow it can do it. Now I know that, no, it was not what I was looking at. That this thing fell up when it collapsed, the guy's video, when it collapsed, that I could do another video of it, but I'm talking to you now, that bottom section just fell the fuck away. That this just removed itself. Hold on. That this just got out of the way. It's the bottom half of it, damn it. It's the bottom half. This is the top half. That just removed itself. That there was no tearing itself out. And maybe I'm gonna get lucky and it's in the next image. See what we got here. This is from the MCM's video. I said, look, all of a sudden, by chance, they blackened everything out, probably to hide these voids. They're like damage in the top of the nodes that we can almost see right here. That's the shape of it. I don't know if I loaded all this up in a previous video, but sharing with you now. And then all these guys, look at them. Everybody's worried about the end of number 11. Everybody, and there's another video image of it too, but number 11, they all know that this is a shit end, that this thing has been repaired, and they're all worried about it, that this should not have gone in place. Oh, good shot. So right here is where that crack is. This right here, this little bit right here, there's a 2 pieces of rebar and that there. Let's pull this down. Let's get you a reference. Let's get rid of that. Get rid of that. I need to reference this stuff faster. Referencing it faster. This. Here's your rebar. There's your post tension cap. There's your pier. Your support. Your end support. So it would. So 2 strokes. Yeah, I'm looking at your comment now, and I'll get to this. Yeah, it will. No, will it concentrate the load? I don't know what you mean by concentrate. The loads will be partly in that node. Whatever loads are transferred there. I don't know the calculations. And also by default, since 10 is now, loads will go down 10 and wound up at the bottom of at the deck at that point, right here. So this is 10, this is 11. So as this is not participating, all the loads are going to come down here to some degree, and land mostly here, not on the outside too much. I don't know how this is configured, but I'm saying it did take some type of tension action going on here because of this crack here, this opening. It could be rebar, guys. This could be just a rebar conflict, except for it is kind of out at the edge again. I'd love to see the cage, you know, the setup of that, the framing, the setup of that. Here's the chains holding this guy up left and right. Like chains would help it now, right? Maintain stability. Back to this one. And he sure could, but back to this one. So 10 loads are going down here. It's the center. It's transferring loads down the center. We have post-tension, this post-tension cabling going down the length of this deck, all the way to the other end. It doesn't come over here. It goes all the way down the other end. It does not come over there. It goes down the other end. All of these are going down the other end. They have longitudinal transfer post-tensioning cables also, which I ultimately found. They're coming this way. At this point, we have drainage. There is no post-tensioning going down the center, as I could not find. So the loads have to transfer. The closest it's transferring the loads is from the post-tensioning longitudinal transverse post-tensioning cables coming across here. I looked. I don't know if they're exactly right here or not. I didn't have enough details, and shop drawings could change everything anyway. But let's just say they are under there. Fair enough. They go across right there. That's beautiful. My phone's dying, so now I'm not going to be able to follow your comments on that part. I'm going to shut down my phone. Let me, hey guys, give me a second. I got to plug this phone up. I'm going to need it when I hit the road. So just give me a second to plug it up. It took me like 40 seconds. I got to wait 20 seconds. Okay. I'll backtrack it a little bit. I'll backtrack it a little bit on this one. So imagine, I don't know where I left off, what you guys heard. So I'll just do it. Imagine this piece of steel going across all these members here, intermittent. A piece of steel going across all these members right here. This is longitudinal post-tension cables, right? Going all the length here. Now imagine I put a steel member across all of these. You can, these tendons, imagine you can visually see them. Now, if I put a load on top of the center of that steel I have here, it's going to have to, for it to deflect downwards, it's going to have to push all these cables down. These forces, I'd have to defeat all these forces to get any deflection. They're all coming in contact with it together. Now imagine a transverse post-tension cable coming across here. I think they're spaced roughly 2 foot 6 inches, 2 foot 9, something like that, apart from each other. So I won't be able to add a bunch of them right there like that piece of steel I described, but I'll add one cable across there and I'll put another one 2 foot 9 and 2 foot 9 away, 2 foot 6. As the load comes down number 10, it lands directly onto the one I'm making up now, that being there, but I don't think there's one directly there. But it lands directly on top of that one. That's the greatest resistance it's going to have, those forces. This is all in compression at this point. This is from side to side as these transverse post-tension cables work by compression and compressing this concrete, which makes tension in the cable, which gives it its resistive force. So this chain gets a tension on it by this latch creating compression, closing up, creating tension inside this guy, inside here. Now it can resist the forces coming down. So that helps you imagine that chain across there. You can't push this down as long as this thing remains compressed or closed. I open it, I lose all the tension on it, it falls down. So it's just kind of helping you that way a little bit. So now these loads are here. They're transferring from there. These loads, the load path wants to always go down to earth, right, to the ground. And it sees unsupported span. Unsupported spans are simply, yeah, that's going to be easy. I'm not going through all that. Unsupported span. Let's just do that. I'll let auto check get me. All right, so on unsupported span, let's just grab an image. Unsupported span is, really too complicated. Let's do that. So the unsupported span would be from here to here. Let's call this the pier and pier. This might really work out. Oh, this is going to work out. These are the longitudinal post-tension cables, right? Coming down each length of the deck. This is friggin' going to work out awesome. That was just sweet. So here's your cables, right? And I remember I said transverse cables. I mean, I couldn't ask for better at this point. So here's that transverse cable, and let's call this number 10. And these guys are spaced every 2 foot 9. And this is the center of the structure. Oh, this is friggin' awesome, guys. Look. Here's the center of the structure, but we have to line between the two of them because there is no post-tensioning here. So there's no post-tensioning on top of one of them. Say this is number 10. The loads come down between them. It's transferring all the loads. Say this is a solid piece of steel now, this cable. You can't just push it down. It's not loose. It's taut, like that chain I showed you. You can't just push down on this chain. If you push here, it's equally amount of force to pushing here and here and here. This chain is going to give you resistance all the way across, equally once you tension it. It's not loose. That got wild. So your forces are coming down 10. It's going to transfer all the forces across these guys too, where they have to try to deflect all of these downward. But it's also got the dead load of this entire structure that these cables are trying to resist. The dead load, the deflection. It doesn't want any deflection here. Now we have the two, it's between the two of these guys. Let's come over here. So it's between, here's this lined up. This is roughly the same size as this. In fact, they are. The depth of them changed. The width does not. I think it's 1.9, something like that. You can call it 2 feet. I don't care. They're all the same. So this depth is the same here. So whatever you see here, I can line it up here saying they're the same. You can see before it gets to the post-tensioning here or here, it's using the center line or forces, if you will. It's going to make it out before it gets to the solid, also pure cap, if you will. It's got to make it out. These cables are coming down here. These are experiencing the most forces, the closest, these guys that are closer to the center, transferring the loads out. Just trying to theorize it. I don't have a loads on this. I don't know what each one of these are post-tension to in reality, and how much they really are holding up at this point, how much they've already elongated because of the stresses of the bridge. You know, they didn't retest them, they didn't recheck them after they placed the bridge, which you clearly should have. That should be something that should be mandatory. And now we're at this guy. So we have cracking here. Remember I said, like the balloon, you put your finger into the balloon and the outside the balloon comes around your finger. So imagine this is your finger here, you're pushing inwards, and this is all balloon material. As you push inwards, forces are created outwards. This is how I theorize that this is transpiring, that we're looking at. This is how I theorize that we're looking at this. That we're pushing in, the forces are so great on this one that it's pushing inward, creating that balloon effect, pushing it outwards. This is how I see this. I don't see it as reinforcement or anything else. Interesting, though. I would love to know how this is set up. Is this plumb? You know, my force is what is forcing this outwards? I don't know. It could be simple as the reinforcement in here, this cage, this design, this shop drawings would tell that. Now let's move away from that one. Now, hopefully you caught on now that like pulling a zip strip on package. All right, so hopefully 2 strokes that you're following, and I'm going to beat on it more, that you're following how that transferred. So that's our crack here. On this side, we have this whole member crack. It's also taped off. We're at the roadway, and we can't see any cracking yet. The guy's beautifully covering it. You know, I think I said in the other video, we want to find out when they ordered these banners. When did they order them? Because it would be definitely nefarious and showing intent and what your goals, intent on what you're all about. Now, there's no intent, the criminal thing. If you said it was repaired and you were just hiding your imperfections, well, then you're just hiding imperfections. You know, but structural, hiding in structural defects, yeah. All right, so here's your reinforcement there. And this also indicates that, all right, so back to this number 11. So the loads are you know, we have no drawings to say the loads are, this whole bridge, the loads are designed to come down number 11. But clearly that's this truss system, you know, but I reserve the fact that they might do some other crazy designing here, saying that we all thought it was going to just come over to here and transfer down here, and this was just redundancy and extra spare parts to hold the canopy on because we like to hold the rain off the people in the 16-foot radius. That's what I reserve that for, guys. All right, now that would be this one. Oh, I'm already finished that one. Oh, that was downloads. That's over here then, Seagate. Oh, it bounced me out. Anybody cares enough to slow it down and see what I have on here, it's I'm not that secretive. Anything on here is not a secret. I'm not that, I never would put secrets down in written. Secrets are kept in your head. Can't write down a fucking secret. Where's your secrets? Oh, I got them written down. This is an interesting file that was created by whatever reason. It's inaccessible by me, created on my Seagate. That's why I don't do that stuff. This is another, obviously it's not 240 kilobytes. It's something else. I'm digress a little bit, but this is, there are programs out there, guys, that can make all this stuff down this small, entire video that might be 4 gigabytes down to 248 kilobytes. This is the shit. I've got it to work. This is stuff that's beyond my my abilities. Look at this. The data. It's their secret stuff, man. I just accept it now. I already went down this path 2 years ago. It's secret stuff, and that's why I use the external drive. It sometimes it reveals their secret stuff, as a computer cannot. But they'll put that shit on your computer too, on your computer. And believe me, it's a full file. That 248, you can play it. It's a real full video. Don't ask me how the hell they do it. But I spoke to some engineers once, and they told me they couldn't believe I found it. It was from Apple, and also, I'm sorry, it was from Google. It was from T-Mobile and Apple. They couldn't believe they shared all his personal phone numbers of people's cell phone numbers. I was supposed to call and just tell them. I said to call and tell them what you found. And each one of them, first things out of their mouth, how did you find it? And that's a longer conversation, guys. Never was my computer. I'm just a child, they call it. I did research on that. I'm just a child. That's all they consider the children. We're just the children from them. This is nothing there. All right, so this is over another forum. Any of you guys watching from the other forum, no disrespect. I just, people told me the 1112. I had to go find it. I had to see if it had any substance. I had to read it. But here's 11 and 12 shear thing. And so this is what it's about, right? It ultimately, is NTSB going to go along with this other forum? Because obviously it got traction. That's why it's important. It got traction in the news, with literally the news saying about this forum specifically, talking about this forum. There is no other freaking forum about it. So they're talking about this being shearing off and all that. There is none other. So this is not possible. This is not technically possible. This shearing. You can pause, you can read it, but this is talking about shearing. So no offense to any of these guys. If I could block their name, I would. It's just a screenshot. Again, it's shearing. This is another thing showing the shearing, how this moved off. This moving off. This has number 11 pushing 11, 11 pushing 12, 11 pushing 12. I guess I won't beat that up anymore about that. 11 cannot push 12. At this point, 11 can't even hold itself together. Literally cannot hold itself together. 11's not doing any pushing. 11 has no ability to take those forces from the bridge and push it. There's only about 4 inches of concrete here from here. This is nothing now. This is a crack. The crack did not start from the surface. Okay, so when you guys see cracks, they did not start from the surface. I'm sorry. Some shrinkage cracks, like when you're first installing concrete, it's a different cracking altogether. These cracks do not start from the surface. They start from a force applied, and they're representing of tension from the opposite. So I can pretty much visualize. If I can go backwards into this, I'd find steel. What I'd find on the other side, somebody took a jackhammer to it and a force was applied, and somehow a flat plate was not, because this is the line of it. So I'm back to steel again. This is steel, and forces was applied, and it went this direction as we're looking, and we have it. Hey, look, this water stain or whatever it may be is also a mark, a benchmark indicator. Let me see if I got any comments, if I triggered anybody with that, with any of my. This is pretty cool. Trigger anybody? I have a few fuzzy pics someone sent me. They show an angle from their intersection side, different perspective. Yeah, sure thing. Two-stroke. Sure thing. If you want to share it online, you can go. I forget what it's called. I've shared a lot with that. JPEG. Shit, you guys remember what I share under? Yeah. JPEG files. I like seeing what they think I'm going after sometimes. Plastic and metal payments at Google. That's not my search, buddy. But I wanted to finish the JPEG one because that one looked interesting. Something popped up. Now it's gone. Back up one. JPEG Mafia. Have you heard of it? JPEG more. Anyway, JPEG Mafia. You can't put URLs in chat. Yeah, you can't. You can put them over here. The URL over here, and I'll just tell me you post it, and I'll it's fuck, I forget how I was sharing it, guys. But back to this. That's wrong one. Right, so 11, 12, that's the ripping. I'm trying to find that one. I guess I took multiple screen, no, different people. What's this one say? 11, 12. So you've got movement going on, separate, individual movement. That's the default alone why it can't happen. Ntsb. And that's how I originally found about it. Somebody, PoxyBot, mentioned me over here in that forum. And the pump was running. Well, that appears the pump is running great. It's okay, so there's no issue. That was just one of my videos I posted, making the canopy soft around the blisters. That's his wording, quote, soft, not mine. But I don't think that anymore fully. More details. There's a ductwork. So these are the images. I'm going to fast. I think we already went through this one. This one's crushed. This is where original break happened in the canopy, I believe, in number 10. This is what you'd want to look at. That was before the video. Once the video came out, all bets are off. All this stuff is some awesome data, though. And there's the material, the rod, for anybody who hasn't seen it. My hat. Nothing to learn there at this point. There's the jackhammering. This is number 10. So this is the rod. This is the top rod, which is this one. This is number 11. This is the top rod. That you know, I can only say these fuckers, right? And I don't know, the guy, I don't know how new he was or what's training he's had. But, you know, this is that's, you got to be smart. You know, let me tell you something. I was teaching my girl last night something, showing you that I can control her, that I can get your anger, I can control you through your amygdala. So literally, I grabbed the scissors and I just held them in my hand, waving them. Now, I'm not doing anything, just waving them gently. Imagine me doing that to you. It might be pissing you off right now. You guys interpret the threat and the issues. You have to listen to the threat and issues. If you feel like it's a threat and issue, just don't sit there and wonder, okay, what's he doing with the scissors? Step the hell away. If you felt that something was wrong, step away. Yes, me playing with the scissors, not cutting a piece of paper was inappropriate. So your brain told you this, hey, he's not cutting anything. These scissors action, something's wrong. It's inappropriate. So I'm telling you now, in life, step the fuck away. About everything that represents the scissor effect, if you will. This, if you knew you had some post-tension training, you knew you'd never fucking post-tension anything like this. There is no post-tensioning of this. This doesn't even make sense. There is no sense. If you were going to close this up or whatever, this is just trash. This is not even something you attempt to fix. There is no fixing this with any, this is a part now. It's done. No fixing of any carbon fiber or anything else. It's done. So this guy that died, you know, if he had any training, he should have paid attention to the scissor effect that I just mentioned to you and stepped the frig away. So back to this one. This jackhammering to access a node, to access the plate, done. I'm not doing it. You got to step away. Here's the plate. Here's the other one. There, of course, is my hat, but that one, I don't know what the hell that is. Here's the, now I said this in the video, and now we know this to sort of be true. School's color or an attempt to conceal damage to blister bars, blister bars. This, school colors, I said, this color blue everywhere, or was this an attempt to conceal? Now, with that said, I would say it's an attempt to conceal. I don't know about you guys, but I would say that is an attempt to conceal this shit, these repairs. I'll look at your comments in a minute and go forward. And that's another version of the same thing. Sometimes they do double shots. Oh, that's a whole, look, that's a whole, how they make sure that my videos weren't getting out. They threatened to demonetize my whole damn channel. but they demonetize these videos so they don't go anywhere by saying that they put a cost. And this would be a compliment normally for somebody to get 27.87 cents per 1,000 people watching. The thing is, the person has to pay this much. Who the hell wants to pay $28 to advertise on my channel to watch about the collapsed bridge? Only you people like you and I need to access it. So they made it inaccessible to people. And that's some nasty shit. All right, this is me working on some forces and looking at this thing, but 2016 drawings, trying to figure all this drama out. And, you know, it was just driving me crazy. This, you guys can pause it and look at that and go, yeah, it was unfathomable, whatever. At the moment, I have turned my attention. Now, Madrid, they hit me up on my channel again. People over there, thanks, whoever's over there, they write me, telling me somebody wrote me, talked about me, and I go over and take a peek. And anyway, he said that at the moment he's turned his attention to number 11, 10, 11, structural engineer guy, believing that what I'm saying about 10 and 11. But now we have different data. Move on, 10 different data. This one is what I did a long time ago, FIU bridge collapse, 12-foot modifications and canopy failure. So it's a 12-foot modification, not 11-foot extension, and failure via load path versus shear failure. Shear failure. I said this. Oh, this is a screenshot, so I don't know when I screenshotted it, May 13th. That I said back then. This is number 10. Loads are going down 10. This 11. I just couldn't find it buckling. If you guys heard me in the video, I just kept going. I just can't see buckling here. It drove me crazy that I don't see 11 failing, that loads are supposed to be going down 11, and I don't see the failure. It killed me. And now I see why I didn't see the failure, because 11 wasn't taking the loads. 11 was not taking the loads. Even if it did, this was an impound, as I call it now, failure. This whole design failure. It's not the transporter failure. They can talk all that shit all they want, because the cracks were shown in the impound. I don't know what I have there. I'm just moving on. And this is 2016 drawing stuff, not 2017 yet. So this is data that I'm going back in time, guys. So this is in my screenshot. So this is showing me my thinking process. Initial crack of canopy. Yeah, I'm still with that one. But for clarity, I thought it was a center bridge failure. So this one might be, at this point, now this is after seeing the video, because after seeing the video, then I'm saying the initial crack of video. Because it drove me crazy that when I saw this MCM stuff. Take a peek at that. What's this one? Right, this is all the bullshit, cover up. You can read it, try to analyze it like I already did. Now we know it's just fucking bullshit, cover up, bullshit. It doesn't amount to anything but nothing. Right about here, I believe, is that crack, that hairline crack that we see. Here, and take note of that, the two concrete covering materials. You know, I was wondering if they covered the whole damn deck. This is just so odd. This is this finish, and then we go here. I think it's right about there, that concrete. Now here's that crack, and here's the ripping of this all member, and I think this is a J-bar sticking out. There's some rebar, the detail. And there's the back of that post-tension member that's supposed to have one of the members that could have, in theory, popped. This is the one that they post-tensioned already. I believe this is number 11, not this one. The one in the bottom is sitting on the ground, so this will be the top of 11, the one they already post-tensioned. As you recall, they post-tensioned the top already. They post-tensioned 3 members, and they worked their way down to the 4th one. So this would be the bottom of This would be this. This would be the, I call it number 3 in the post-tensioning schedule of this repair. They post-tensioning this one, the bottom of it back here, embedded into, going down in the path, going into the pure cap, pure base cap. So that's what we have there. Let me look at your, see if you guys got anything for me. Yeah, they removed the forms, I think, to see what was going on, to see how the structure would hold up. They had doubts. The scissor effect, they were testing their scissor effect, though, you know, by seeing, I guess you'd have to step forward to see if I'm going to stab you with the scissors or not. Of course, I would not, but this theory, when you strip the forms ahead of time, ahead of schedule, that means you had doubt about your own damn system. You had doubts about something that you wanted to take a look at it right then. Or also you were saving money because you'd figured it'd be cheaper to strip the forms in the impound than, and there's my magical hat moving around. In the impound, remember, it moves here, moves there, moves over there. Everybody but throws the fucking thing off the deck. You know, they don't get rid of it. That's me swallowing liquids. All right. Moving on. Here's the X marks the spot. This is that ripping that I said was ripping. It was bullshit. This ripping, we don't see the other side. NTSB is holding out on photographs beyond belief on us. This is on this side. This shifted over towards me. This shift, if it was from the other side, say I was able to get my hand on the other side and force it over, then I could create a shift, right? So we'd want to see on the other side a crack. We'd also like to see this torque. At that point, I'd probably torque this whole thing and start ripping this, torquing it. So we can say it's not a lateral movement. It's a lateral movement of rebar again, internally. Lateral. It's a movement of rebar. Lateral is a direction, right? And it's just a movement of rebar. I don't know if it's lateral or not. Lateral to, let me do clarity. Lateral to, this is one side, it's lateral to that movement to this side. It's an outward movement. This is a secondary outward movement. Amazing, you know, it's you can see that it was never under compression, in my photographic opinion, because you can find very fine tips that this was never crushed and then took a secondary movement opening, because you see the very fine tips, they would all, if you could push this back, they would all marry into each other beautifully. So this is one movement outward. And to help you with that, let's go with, this is, you would have a crushing, you could see everything outward, everything matches like beautifully. Pixels, those are pixels. Then we have something falling in. So possibly this was a upward break first, and then an outward movement causing these materials to fall down. So this would be here 2 movements. One forcing upwards, causing this break, and then an outward movement causing the broken material to fall inwards. So you see the forensic stuff on that? I live for this shit. Back to this. Agreed, Hermit. Every square inch. Let's go back to that. There's that bar again. It's not popped. This, you could say that this is holding it up. It still could be internally popped at that point. It could be down there popped. Also, the problem I have, guys, is at the point this bridge was being falling and collapsing, it could have created this pop. You know, it broke, right? Both caps are on each end. So it broke somewhere in the middle. So did it break while they were tensioning it, or did it break while the bridge was collapsing? Okay, so let's go forensically again. If it broke while the bridge was collapsing, it would first elongate as long as it could before it finally broke, and then you would find the break somewhere about where it broke. Right? It fails. It no longer is springing back. Now, if it broke while they were post-tensioning it, it would break, and we would have the lengths equal. That this is no longer holding on. The tubes are hollow. They're not concreted in. So we would basically be able to put it back together, find only the broken point where it's broken, and you'd have your answer, whether it broke before or after. Hopefully you can follow what I just said. If not, I'll reword it. I'm looking for your comment if you followed that. I'll be able to see your comments pop up. I do that, I'll be able to see it change pictures. Pictures right here. All right, here we go. I was just showing how close they were in a conflict I had with so close to materials. And okay, what we got here? This guy says clamping, the best post-tension things. Clamping the shear horizontal, whatever. I didn't quite follow that, I don't think. I think I looked at that. Back to shear, right? We're back to shear. Pass. All right. I was informed that Erica changed the post tensions. This is bus throwing people on the bus. I see a comment I thought just popped up. Yeah. The cardboard model was badass. Thanks, Hermit. Your cardboard model contained truths in the. It showed a bit. Showed bit that held together. Yeah. Yeah. Thanks, Hermit. Yeah. That cardboard model was badass. Here's this one, this rendering of it. This guy went as far as this way, and this one I'm like, sure, I'll share with you. I like it. These computer models. Everybody, if you go about with your conclusion that shearing happened, and then you program a computer, I think you're programming in shearing happened. And so this guy is showing that he's proven that 11-12 deck connection failed. He used a computer model. The computer model, if this was true, should show. I think computer models suck dick. And I guess if you like sucking, it's okay. But should have shown this. Which computer model showed this? Not one. Not one computer model showed this. So this is why I don't go in for the computer models, guys. They told you what they do. So where did it go? I lost my lost where you guys are. There you go. So computer models suck. When people tell me computer model done, I'm like, no, give me the real math, the member, the length, the concrete, what PSI, everything. I want it old school. You give me a computer model, I'll do it for you. I'll just be your construction supervisor, but you know, that's your shit. I'm not doing anything on it. I'm accepting it 100% as for face value. Yes, if you start with a theory, a computer model will confirm it. It just reflects your opinion. Yeah. I'm open for data, guys. I'm still open. I got all this. I'm willing to change my opinion 100%. You could tell me somebody went up there at late night and put a saw cut in there. I'll change to say the cause of the bridge is the guys put a saw cut in here, and all my other videos should be discontinued. The moment I can't do that, I'm too vested in my opinion. It's wrong. You got to be able to change. Even the shearing, I can still go with shearing. You just got to show me how, and then I'll say shearing caused this to happen. You got to show me how, and I'll say, wow, amazing. I'm saying it can't happen because you need movement. To get movement, you have to have movement. It turns out, isn't that some shit? To get movement, you got to have movement. There was no movement. We got a beautiful video. I'm sorry, you have to have movement, in this case, elongation. In all their drawings, they're elongating. They got this moving. They don't have the rest of the bridge doing shit. This top magically is forcing, all the force is sliding. Let's talk about that shit. This top, let's find another picture they had. The top is magically sliding. Where's the damn thing? Let's trigger myself. Sorry, guys. You heard it in my voice. Let me go trigger myself. I guess we're further back than I thought. Don't even waste your energy on that one, that one there. Believe me, I was. Let's go. So the top is this magically slides number 12 off through the loads of the top, not the bottom, because if the loads on the bottom are going down to the ground, it's pulling downwards, meaning it's pulling everything in concavely, right? Like this. So magically they have this stable. The bottom is 100% stable, and this number 11 moves number 12 off. So it magically elongates, which is impossible. It can't elongate. That's how it would get movement. It moves over. Wait a minute, but this doesn't move over. Wait a minute, this one doesn't move over. Oh, fuck, wait a minute, this one doesn't. Wait a minute, this one doesn't. Oh, we got pictures online after the collapse. This clearly didn't move over. So they magically having this thing moving over. It's just ridiculous. And to have that this moves over. And that's why that forum drove me crazy. And I'm sorry if you guys are some of you from that forum, you know, I know I'm triggering you. If you got to follow other videos about amygdala and stuff like that, you see that the trigger is because your files, you're too strong into it. Here, this thing is beautiful. Look at this. Look at this sliding off. And they prove it. He proves it with the photograph. And then there's a video of another guy showing it with using these red markers moving. It proves it with a photograph how it slides off, and it's sheer. And they do newscast on how it shows it slide off. So I know they coming from this damn forum now, and I'm like, that's the only thing, because the other engineers are scared to speak up. The ones that they do hire, they're like, you know, whatever, kind of soft stepping. So there's another one. And there's the arrow showing the force. This one going this way, that one going that way. And it's shearing off, and there it is. It's like, I forget what they call this. It's, I actually talked to my psychologist about it. It's, because I forgot the word, and I need him to remind me of a word. Something like conclusive dementia or something like that. Conclusive. It's some wording, because I told him, I actually talked to him about the form. I said, look, man, what's going on with these people? And he's a good friend of mine. So, just so you guys know, I always recommend psychology. Not always, but I usually do. I do coaching too for people. And sometimes it's beyond my ability to coach somebody to teach them which way to go. So I recommend a good therapist which way or another. Not always the same therapist, based on what you got going on. I always believe in the human mind, man. It's beautiful. Disinformation agents, yeah, you can make me go down that way, cognitive. Yeah, so this sheared off, yet this is also intact. This looks like a 90-degree here. So I was able to push the ass end of this out, and this stayed 90 also. Amazing. No compression at the top of it, causing it to flex, and now it did all that pushing off. It's able to still hold this up. It still has the strength to hold it up. I'm being facetious. That's the node that my man, let's see if I can remember his name. I'm looking at my cell phone in my mind, not in real life. Oh, I shouldn't have said that. Two-stroke was talking about the forces in here. See, two-stroke, this is all acting as one at this point. It's all concrete. There's the concrete around the ductwork. Clamping shear, interface between, yeah, you know, that triggers my ass. And there's that one. Okay, we're back to that. And there's the shear, and oh, this is when it fell down. So first it sheared it off. What is this? Blister. There's the cable, right? There's the cable. This sticking out, right? Oh, anchor plate. Now let me read it. Whatever. Sheared. Shear my ass. Here's another one. Structural guy proving it's shear. Truss is safe if it can be restrained by the shadowed concrete, right? It's got to be restrained because this is shearing it off because the force is coming down there. But guys, there were no forces, as we know. But they didn't use they fell in line with each other. I forget what it's called. They all fell in line with each other. And somebody wrote me that how come wrote me on the side, and I don't know if I left a comment out there. And they said, how can you, look, I found this there. How can you, credit to this person, how can you go against everybody else? And I told him, I said, quite often I'm the smartest guy in the room. That's what I told him, cockily. There's that break. I found I was looking for images, so I trolled their site and I found the image, found this image. And what is he saying here? I repost photos by anomalies. There's anomalies all over this thing. But I just wanted to show you this part, what I'm concerned about, that little bit of concrete, and that's that member there, that longitudinal cable. And there's those two pieces of rebar. And that's this guy. Right here again. That's his first piece, second piece. Just want to add it to you for data in case you guys see something and say, look, you're missing this right next to it. I got nothing else for you there. That's on that other side, which is cool. And this is another shot of it. And there's this. Okay, so this is bent outwards. This is more data. Bent outwards. Let me move this over in the screen. Damn it. I can't see more. It looks like it might be bent outwards. It wasn't re-bent, was it? What we got here? Fact of life. Fake of life. Yeah. All right, so slide this back over here so I can see your comments. Go in here. So that's that one. That's on the other side. That's why also I did a video showing that this is not, this is a screenshot of their stuff. Showing that this is why you see none of this shearing away. At no point did it ever shear. It bent, hinged, and pulled this back around, as you call them, out of the video. And none of it couldn't even break the PVC piping. But that still didn't stop them. They still went ahead with their shear. And somebody wrote me, I don't know if he was trolling my ass, but he triggered me to some degree. I read on him. Then it turns out I went to his YouTube page. He's got a damn guitar in his hand. I'm not saying that engineers don't play guitars, because I've seen quite a few of them when I troll their pages say that, playing music. So I'm just saying there's some guy playing a guitar trolling my ass. All right, so this is a structural guy saying critical shear plane, maybe not much reinforcement here, tension, deck. Deck went this way. This part of the deck went that way. This part went down, and the motion was a sliding motion off of this way. And the force was down off of this. So he's got forces coming down 11, coming across 12, which is 12. So to shear one object, they got to go different directions, okay? They got to do different directions. You can have that. You can have one object stationary and the other one going different direction. You can have the other, you can trade off. This can be stationary and this going. This can be stationary and this moves. I don't know how that would create shear. So in this case, we'd only have 12 stationary and 11 doing the shearing. But 12 would have to be stationary to shear. Unless you're saying you're shearing from the deck. In this case, this guy is implying it's shearing from the deck. So the whole entire top canopy is shearing, pushing off, 11 and 12 moving together. He doesn't have an arrow there, good enough, but maybe that being in blue is indicating of that. This went that way and that went that way. Of course, we know that's not true because these two stayed together and fell down on the ground. So this person, I wouldn't hire to engineer me. All these guys that did this shearing thing, I wouldn't want them working for me, putting together fucking steps that with the plans already prefabbed. Frankly, that's what I think of their engineering skills. I don't have to support them. Fuck them. I mean, it's, they didn't come back and say they're not retracting their statements. I've been watching their little website. Nobody's going, I've got it wrong. Oops. So everyone I said, fuck them. I take that back. Remember I said, I don't stand on permanent ground. I'll take it back if they say I was wrong. not me, that they were wrong and they now need to reevaluate this and figure out where they went wrong. That means they can learn. That means they can still progress and learn. But they're the persons you could hire to represent, to be on the side of the wacko, whatever that place is, MCM and all of them. And here we go. This is proof again because he did a beautiful colored version. So this is nice. And what we got here? We got this rotating downward. We got this force going upwards. I'm just moving on from that. I guess I took a photograph of it because it was funny. And I did that a long time ago. There we go. These pins. Epoxy bot. I want to talk to him about epoxy. What are you saying here? Oh, this to me, it represents actually that the load path is only on top of these shims. To him, it represents these things here. To me, it means the entire 950 tons times 2 of these on each end. Your loads are actually only on these. These are point contacts. You do your math, come out per square inches, and you've got what you really are transferring all the loads to. You've got gaps in these also, but you've got reinforcement in there to create like a bridge effect, header effect, a girder effect, tying the two together. Ultimately, these are shims for leveling because this couldn't be off more than some quarter inch or something like that. This also is an issue for me because the pockets, are they big enough? And what the fuck are their intentions of these pockets? Clearly not to hold the bridge on, right? But how big are the pockets now in the structure, and what void do they create? And they're in line with the center of the structure apparently. And the center of the structure to me is dangerous to align any weaknesses with them. And you know why? Because that's the center of the whole canopy and everything else. Hopefully I'm wrapping up. My girl wants me to take her somewhere. And here's this, this is blowing out the back. This is what someone actually sent me saying, look, you can clearly see that this is coming out the back and this and that. And I don't have much to say about that. Here's 11 shearing again, commenting in there. And that just more stuff. I would just hope they would go a different way. Incidentally, I did comment in there a few times under another name to try to see if they can go another direction. And I deleted that account. It didn't go anywhere. And I was like, you know what? I'm just leaving them alone. They were stuck on shear. I was trying to play devil's advocate, and they were stuck on shear. And I was like, I'm leaving them alone. And that's that until I just went back there and posted again. And they're leaving me alone. Of course, some of you guys do go there because you share it with me. I appreciate that. But that's their source material, man. This is what the press is getting. It's terrible. They're getting this terrible press information. This is not shear. And who's this one? The Green Llama Structural. See, this person says they can amend, so that's good. You know, they can grow. And moving on. 11 and 12 together. Had enough of that. Another structural guy. The shear. I'm going to fast forward. Now we're back to my pictures. Okay. So this was 2016. This is before they showed us the post-tensioning inside of it in 2017 drawings. There's a screenshot. This is a screenshot showing the pixelation, showing the movement, showing the break here. This because the loads are down 10. And I said that acted like a node. Okay, I'd like to explain that to you. Why the break is here and why the break is there. Why not in the middle between, why didn't my theory and why it didn't resolve itself between here and here at the center, which would be the weakest point. And remember, it's going through post-tensioning cables here. Because it's a node, it's like a plate. And on the opposite side of that, on the edge of the plate, is the most shear point, the most point of where it transitions from that onto the decking, if you will, if you can visualize that. Same thing at the top, where it transitions onto the deck. The loads transfer from the node, from the plate, onto the cabling at that point. That is the weakest point. And I can say that factually because we have a video of it now. It's not just theory. And I'm saying it based on that. So what if I load this elastic creep shrinkage total? What did I load this up here? I have no idea. And for this thing to shift over, creating that shearing effect, these would no longer be in place because the bridge would have to separate somewhere in the middle to allow for that movement. Magical, we have a video of it, and no bridge as I know of that's under compression in the top and the canopy is ever failure by separation as far as it getting further apart in the compressive part while it's under compression. I guess you could come up with find one, or if you could find with a pure somehow Cape. I'm just craziness even thinking that. Never mind. Watching, you've learned a ton about watching. Thanks, Cognitive, and hopefully you know that other people will catch on, powers that be, and not accept that crap. And that's just one of my Tiger Grant stuff. The rods were apparently modified to the plans added to the bridge after the design did. So we already know that this is a release from this is a video. I think this is the format of Miami Herald and them talking, but sharing it. But one report by U.S. Senator Rubio, which we know is in the pockets, is in a, he gets a lot of money from MCM, right? $75,000 plus or whatever. Had the crews tightening, they were approximately tightening the rods. He said, had the crews tightening the rods in an effort to close the cracks, leading to speculation that over-tightening could cause the truss to shatter. Okay. So this, Marco Rubio had data. With that statement, he had some awesome data because we now know that that post-tensioning could not have, let's see what he says here. Because this is the day before, he's just tightening the rods in an effort to close the cracks, leading to speculation that over-tightening could have caused the truss to shatter. We know damn well he couldn't cause this to shatter post-tension, doing any compression on it. There's nothing to shatter. It's just in pieces. All you're going to do is create, if anything, you're going to pull down. Fuck. This is what I put in a previous video, and then I'm talking to you guys. This is what I pulled in a previous video that I said it couldn't happen. Son of a bitch. Look, if this isn't here, right? I said you could pull down on node number 11. Maybe I'll find it. Remember number 10? I said if you could pull down and create a crack. Where the hell is an image? Where do I have an image hidden at? It's like playing a game. Twister. Remember I said if you can pull down, just use reference your brain, guys. I do it all the time. I make my brain find something before I try to go look for it. So let's see, you heard my brain out loud thinking. Remember I said that, you know, if you could tighten this one, you can create a failure in here that would that could start making this node fail. Maybe the failure's still in there, but since now this is all cracked to shit, the forces you apply are no longer really in compression, right? But they are. We need to see it after the fact, because that still can resist, that concrete can. But you're creating a hell of. You're not creating a. It's no longer a tube, a duct. It's. I don't think it's duct anymore. I think it's got failure on the half side or quarter side of this thing. I don't think it's. Remember the Ntsb shot showed that I said it's ripping out. I think the fucking thing was split by failure beforehand, by the rebar reinforcement being so close, buckled it away. So now you're post-tensioning. I have no idea what I'm talking out loud with you guys. You normally post-tension a duct, right? A tube, concrete all around it. Now imagine if you had a duct, but you had it split in half. When you started loading it, post-tensioning, you're creating two forces on opposite sides. One can take the force more than the other, perhaps. Could that create a force inwards? But you would have to see buckling here, though, to do it. You would need to see you would need to see compression, and I don't see it. But I'm adding that to the fire now. Going to here. Don't feed into that too much because we need more images. But I'm just documenting it for posterity. Where the hell is it? Rubio. Oh, that's right. I was at Rubio. Here we go. So Rubio came out. Remember, we now know it wasn't just a senator. He's the mouthpiece, if you will, for, you don't give him fucking money for free. He's a mouthpiece for MCM. This guy ran for president too, incidentally, if you guys remember. And Trump chewed him up, made him think he's so soft, which he apparently just looked at Trump like a school kid, like Trump said. Anyway, one early report by U.S. Senator Marco Rubio. You know, look, you see me beat these other engineers up, right? I'm sorry, that's the way I'm built. You know, I don't have that let me be tactful thing. I lost it. If you want me to be tactful to talk to you and communicate with you, let's talk about that. What part of tactful do you need? And I'll get to that section for you. But, you know, I need to know, you know, you need to give me your source files. Why? You know, because your mother talked to you softly and you can't take criticism. You know, then I got it. Let's talk about that. Let me get you some therapy to get rid of why you can't take criticism. And ultimately, you just need to, it's all about the files. One early report by U.S. Senator Roy, one early report had the crews tightening the rods, which we know they 100% were. So he mentioned a fact. And we did not have this fact. We weren't sure if they're tightening or loosening. And I said they were tightening because they already reported that they loosened it before the bridge was opened. And I put that in a video. So I said, therefore, they were tightening it. Therefore, they were doing repairs, as you guys recall. Sometime after that, I was able to get real data. Anyway, so in an effort to close the cracks, leading to speculation and over-tightening. So this is a fact, guys. This is a fact. So this is what Denny Pate was doing. Denny Pate ordered that these be cracked. These be cracks. These be cracks be closed. All right. So that these cracks be closed. Using post-tensioning in this angle. This is what I'm saying. Denny Pate, I thought he was a structural engineer. I don't get it. I don't get how he thinks applying a load in this path closes this path. You know how they separate. I mean, I don't fucking get this. That's what I'm saying. That now I'm saying that he can say he had a mental break. Maybe he's got a stroke or something. He should go get his brain checked. I mean, I mean, you know what? In the other form, if I start seeing other engineers mentioning that this should be closed using post-tensioning as they did, that it should have closed it, then I know it's me that needs a fucking doctor. All right, so let's reverse that around. The move forced, because I'm the dummy then, the move forced a change in the carefully calibrated plan for moving carefully calibrated my ass. That's just propaganda shit. Oh, it's not loading. Yeah, this is where I said the chaos mathematics. You know, this is just craziness. These forces from the bearing plate align with all this stuff. Remember, I only know that at this point, I don't know if we have that. I have the image yet out of this, but I know they're working on this, creating the forces. And I'm saying that the counter force at the top, what's it say? Low path is creating stress on the underside of the canopy, which is that's still a fact. That's still because you're creating top forces. Yeah, I don't tie that into this one. Oh, at least we forget these. Wow, shit. Forgot all about these guys. Remember all these cracks here? But they couldn't share these cracks. That's just bullshit. All right, the other thing is I wrote notes and I don't have them with me now. They should clearly be able to speak up now about what Ntsb released. This is the formula you use to try to calculate this, guys. Try to calculate all this drama going on here, you'd be using this formula. And I just changed it to chaos mathematics for you. Look, now that the Ntsb has released this, clearly they should be able to speak on this now. Their representatives or lawyers or whatever about these cracks. But they're not. And also, per Ntsb guidelines rules, if you participate in them with them, you're allowed to see before the release, you're allowed to see this and have at it with them. You're allowed to dispute data. Rubio stepped forward because Rubio, Hermit, is, as you saw in my thing where I showed the the lobbying. Rubio is being paid by MCM consistently. And I think Rick said Little Marco. I think that's what he calls him. Yeah, that's what Trump called. Thanks, Rick. You just flashed me in. Good one, Rick. Little Mark. Funny. Thanks, Rick. The literal whitewash. Yep. Hey, was it you, Forrest, that said whitewash? Because I think it was somebody from England. I see your England. I remember I associated that with the England patch. Yeah, I think it was you, whitewash. That I mean, fart. This one right here. Cowboy diplomacy. Oh man, I don't have a lot of data, cognitive. But you know, with the data I have, baby, you know I can put it together. A girl walked in the house the other day. She had a little slight limp, little clip. I knew right then what happened. I'm shitting you. She came in the house bleeding. I said, watch it. I just did the floors. You don't get blood on the floors. Never. I may sound incompassionate, but if you got a medical emergency, I'm probably one of the best people to be jumping around short of being right in the hospital. I'm probably one of the best. Short of not being in the hospital. Well, it depends. No, I take that back. So put it in perspective. If nobody else, if you're on an island, stuck on an island, I'm the best person. If you don't have any other resources, no medical care or anything else. Where's FIU in this group message? Right. So, in other words, I can tease about. It's your emergency, first off, on medical stuff. And this is grazing and things like that. It's your medical emergency, and we'll get to this one. So I know how to stay calm and handle your medical emergency. To understand airway breathing and circulation, and they've extended that sense, but just without using the resources around you to help you through your medical emergency. I'm not saying your ass is going to live, but I'll help you through it. So this is where my dumb ass kept looking at that stuff saying, hey, it peeled away. It pulled out. Wow, it ripped it. What data? Look, and it ripped through here even. I was trying to correlate where this broke through there, sheared through here and all. I'm trying to figure it out. You know, the cable. And wow, I'm working on it in my brain. And I decided that what the data they gave me was what the data they gave me. Now I'm so much pissed off that that thing didn't rip through there like that. That it was that ripped through, causing this cracks here. That this son of a bitch, this was this indicator of what you hiding, buddy? The hell did I just do? Oh, yeah. I'm sorry, I'm trying to look for a different image. This is, it's the top, mind you, this is 11, right? This is at this point, this is already crushed. This is underneath the canopy. We no longer see the clarification. Correction rather. This is destroyed. This is gone. This is where everyone says it slid off. This is the sliding ability. This is the one that slid, that did the shearing. This right here sheared off number 12, which we see here. I'm being facetious. You can see clearly this can't shear shit. It just crumbles. You put any force on this, it's going to peel apart. This is the top of number 11, which is, this is the bottom of 11. As you guys remember, this is what, down here is the ground. This is standing up, obviously. So this is, I didn't flip the image or anything. This is inverted. This is where the Ntsb crew standing and looking. And this is what I zoomed in on because of the shearing. Want to know the PSI and what the forces were, things like that. Is that a half-inch rebar, trying to figure it out. And then try to figure out the shearing of it. It had some elongation before it sheared. So, and for clarity of that, you see the elongation before it sheared and how it sheared. And did it twist? You know, I'd love to put all that back together. I'd be able to reverse this whole thing and see it without the video camera. It'd take a while, but anyway, so this is down. I think he's down 7 inches. I think he's sitting on top of this guy. As he pokes down, I think he's sitting on top of this void here, this bottom half of the void. Remember, this is only like 1'9". We got 7 inches here. We're going to add another. You're going to add what, a 4-inch or 3-inch duct. That's 10 inches to the underside of it. Well, let's call it 7 to the top, and then change it. If I can rotate this, we're looking at 1, 2, 3, 4, 5, approximately 6 inches. So we got 12 inches if you rotate it on this way in this plane. 12 inches to the top of this guy. I'm thinking he's down there, and this ripping is not really ripping, that they're holding out on the images again. And we already saw the fine line crack. They're not holding out totally, but in my other images we saw from Ntsb, there is a fine line crack. And I said there's a shearing at one of my videos saying it's sheared all the way up. And this could be shearing all the way up. Both of these and failing and shearing with this crack, and then loads transferring to 10 after the shearing, because I need separation too. Now where he's sticking his, I don't know if he broke it, but this was a compressive little action going on. We're seeing it missing, and then this where he's sticking his tape in, but we got breaking after that. Right here is what I'm talking about, where we don't have this damage at all, so it didn't do any friggin' ripping. Right here, I'd probably line this up with that, maybe with this reinforcement, that rebar. But this is what I found so amazing, and I was like, wow, now I know what I'm looking at when I see it in the future for like blood splatter analysis, right? So you now, for everything, how this can take the compression of ripping through there, crushing, and still come out looking so beautifully round. Well, that was wrong on my part. Now I'm adding new data that, no, I can be scammed by data hand to me, is what I'm learning now, by like Ntsb sugar hand feeding you this crap. Looking at your comments, make sure you got voice. The stuff that blew out below the bridge collapse. I'm not sure where that is. The cognitive, I'm not sure where you're talking about. Give me more detail, more where that might be. So let's scroll up, and now this. So this now would be an indicator, changing my, now is an indicator of this being more cracked like the other ones. Now that we have the true image of it, that Ntsb is not holding back with their, because you know they edit their software, they edit the video. We did not see, they didn't do it. It's just nasty. It's just nasty. Oops, wrong direction. Right, 5, 6, and 7. We don't have images of 7. Obviously, we don't have a lot more, but 7 was also. And I'm not saying that 7 or think 7 could be anything. We still want to know what 7 is. Frankly, I do. On March 6th. Now, this is, they show the 10th, guys. They talk about the 10th, but we have the project after post-tension bars 10 to number 2 and 11. 2 and 11, guys. Those are significant ones. Those are the ones where the loads transfer off of the bridge onto appear to be the members that transfer the load off the structure, off the canopy, onto transferring loads off of the span onto number 2 and number 11, transferring down to the piers. And what's happening here is that these bolts cracks were found at moment of the inspection. So this is also, as you guys know, I've talked to you about it. People want to tell you the truth. This is him saying he found cracks at moment of inspection. There were cracks also found before inspection, but nobody reported them apparently. All right, so not found, cracks were present at before his inspection. This is very interesting. He's being specific. This puts him out of a lot of things at moment of inspection. How about before? How about after? But anyway, this is very detailed. Also, when was this report turned in? This report is dated this, but when was it turned in? Okay. These have been identified per trust members and the consecutive numbers within the member. The intent is to monitor these cracks after the bridge is fully tensioned. So we're tensioning at 2 and 11. Remember, I talked about this in another video, but now the bridge can't even take the loads that they're tensioning. Moving on, we have comment. My fault, I'm working, so can't text. Well, right now, okay. Moving on. So we see that again, The bridge is failing at points in the impound. Remember showing these small cracks are truss members, small cracks my ass. I told you all cracks are indications of failure. I don't care what, and I use that word largely. Indication of you not addressing the weather, the climate, which we seem to have with that other bridge in Florida. The one that's down there, that seems to be a climate related, not protecting the concrete while it's curing and preparing it and installing it in the formwork, that other bridge, that long one. Now it appears to be the same thing here when I say it largely. Okay, the member showing these small cracks are truss members, small my ass, small, same blister at the canopy at the already stressed members number 2. Stressed. What did I say, 3 days earlier on this one? 3 to 4 days earlier. We believe that this first stressing operation has temporarily created tension on members number 3. Tension in members 10, number 3 and 10. Thus creating cross-sectional cracks, transferring the tension loads to the steel of these members. You see this, guys? I did that video on it, and I got trolled on it pretty hard on that other channel where I showed that steel. But then this report came out, and the guy's making it clear that this steel, you know what, I got to screenshot this and add that to that video. Oh no, YouTube tore me up on that video too. They make it so I'm communicating the same thing twice, double talking twice, saying the same words. They killed me on it. No other truss members within span 1 show any crack similar. Moving on. There's my helmet again. Freaking helmet. It's the bridge top view. There's your loads transferring down these guys. All right, so just for clarity, if you see this and this up here, without the verticals, all the loads are not being held up by this cloud or these cables. They're being held up, directed forces down these guys here. Oh, they land onto the deck here that transfer out to the ends. Now, some of the loads are coming down here. I don't know how much are making it down there because of the post tension. It's not totally zeroed or nothing, but that's what's going on there for you guys. And that's the way I talk sometimes. And there's really nothing to see there. Oh, this is Marco Rubio. The cables that suspended the Miami Bridge had loosened, and the engineering firm ordered that they be tightened. They were being tightened when it collapsed today. Hey, give me a second, guys. I got to run to the bathroom. But take note of that there. He's throwing FIG on the. Remember, he gets money from MCM, so he's throwing FIG under the bus. So who is he working for there? Okay, I'm over here fixing it. How about now? You got sound? I'm kidding. Okay, good. Okay. Where did I leave off? Can you guys tell me where I left off? That's too far to go back. Shit. Backing it up. Right here. Got to remember to keep this open. Can you guys hear me now? I'm going backwards. You didn't miss much. Yeah, you did actually. Left you right here, right? This is where I left you. Did you guys hear me speak about this one? Okay, good. All right. So Marco Rubio, he obviously has. Hopefully, you can hear me now. Okay, I'm gonna right over here. I'm talking. It gave me a spell check. Oh, I see. 2 L's in it. The cables that suspended the Miami bridge had loosened, and the engineering firm ordered that they be tightened. They were being tightened when it collapsed today. This is Marco Rubio, obviously being paid by MCM with all that money paying off now because he's now saying that the engineering firm, so he has access to that 2-hour meeting. Marco Rubio did right here, because in that 2-hour meeting, that's what that took place about doing that. So this turns out to be a fact. And these are dead people. Or I didn't know this guy was dead. I know that he's a worker, right? He's dead. These are deadies. And I don't mean insensitive if some family members watching, but hell, I'm gonna be dead too. So you can be insensitive right back, or ask me to apologize. I'll even help you out. I'm not apologizing to you. Think about it, because they're dead. All right, there's a trigger for you guys on death. Apologize to the living for somebody dead. That doesn't make sense. Apologize. I always thought that was funny. Well, my condolences is all I say. Kind of neutral. All right. There's a span. This is a 2016 stamp of it. I'm getting there, guys. Here's the center line. 1'9" is what I mentioned. I won't miss a single thing I said. Some of it I did skip over. This one, it was showing that the cracks transferring. That this is, I have my original video on my other channel where I talk about. Wait a minute. Comment over here. I see question mark tightening. Who ordered you to do the tightening? Right. That was Denny Pate did the ordering. Okay. We believe the first stressing operation has temporarily created tension. Now they mentioned these clowns right here mentioned that the cracks appear. This is them playing their fucking game still. That these cracks appear on the 13th, like it appeared out of nowhere, guys. They just came out of nowhere like a bulldog, or whatever. I don't even know if bulldog come out of nowhere. The NTSB have obtained additional photographs showing the condition after the March 10th. I'm hungry. March 10th, 2018 move. Blah 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 blah. All right, but we come over here, and we clearly see that this shit was failing when it was in the impound, as I call it. On February 6th, it was experiencing issues a month before that this thing was exhibiting cracks to the steel, as this person says, which they, based on my talking about how this is, exhibiting cracks, how I talk to you guys, and how I made that video showing that it buckling can happen, and the other video on the other channel where I showed how you push down on the plastic rod, I showed it and it flexed, and I said it can do the same thing. I was way ahead of this release. And in this release, they're saying the same thing. With that said, this engineer here obviously has the brain power to say that that the shit's not working. But yet, I would love to know what they're saying too. Their internal documents, what they were saying to FIU. I mean, or did they soft step 100%? This is now a soft step report. Is this because it was going to be turned into the federal government? Oh, I got to bring up your wording. Make sure I don't miss you guys again. All right, I'll see you here if something flashes. All right, so they have the brain to come up with the answer. This one. Oh, beach ball. Okay, moving over. This is again 7-inch apart. These cracks. This was how I put them out there, and then photo 4, 5, 6 is all here, but there is no cracks under here, unless it's a hidden disclosure, right? 4, 5, 6 there are no cracks under there, and here are the cracks on 10. Now these cracks on 10 are interesting. If I'm saying that loads are transferring down 10, they should be compressive cracks, you would think, right? But let's go back to that. Remember, I'm doing this live with you guys. So this is, what number is this? The first stressing creating. So what you guys can jump in if you can. This is number, don't know. They talk about it. They talk about 10. Okay. Has temporarily created tension on members 10. Number 3. We believe that the stressing has temporarily. So this is during this stage. So no, I take it back. This will not show because when they did number 2 and 11. All right. So now we know. So when they did number 2 and 11, tensioning it. Okay. We believe that the first stressing operation has temporarily created tension on members number 3 and 10. Okay. So what he's saying is that. Oh, great. Is that when they tension, this is 11, right? Tensioning this, putting post-tensioning on this, which is actually compression, created tension on this, which is a pulling apart, if you will, away in a way. His description is implying away, this way, and that way. Now, here's the thing about wording. You can be so fucking slick with your wording that I can now change this to compression to a tension wording by saying it pushes here and here, collapsing these two, putting tension on here, forces here. Well, I meant the tension out here. I didn't mean the tension over here and see it side here. I can play around with friggin' the wording. That's why I don't like that. I like percentages. I mean, I hate percentages. Oh, great. I need to find where I left off. Oh. I don't like percentages, and I just don't like the non-specifics on the vagueness on this. Moving on up. Oh boy, come on. I'm saying oh boy because 3 hours. I don't know what that is. I just screenshot some of it, or somebody sends it. That's what that was about. There's the bridge. We see them doing it. They putting the load tensioners on it. This is over there at the impound, I believe, not across the roadway at this point. And I think I do believe that because I grabbed this from the. They're still putting chains on. Yeah, I did mention that. I said that this is where the plumbing is going to go. These are to represent the drain holes from the decking. The plumbing pipes would go down there, showing the voids. No post tensioning in there. These are my notes I had from something else, from the same thing. You guys already got. It's just showing quality. I kind of went fast to this. I was happy that the first time around on this, I'm getting you guys up to speed where I left off, right? This is stuff you saw in another video about not being in compliance. They're just one after another. This is the engineer saying that the craftsmanship. I did that in other videos. All right, this is where I quote on it. You guys, I lost you, so I'll get back into it. And let's see a comment over here first. Yeah, well, I don't care much about grammar myself. Ooh. Is that a failure? Ooh, that was nasty. I'm gonna be one of those marshmallows. I'm gonna call the snowflakes marshmallows. I just changed my name up on them. Marshmallows. So soft and gooey. Hold on, where is that on that? Somehow I got some of my other stuff mixed over there, didn't I? That was the food one. My nutrition stuff I post. Shit. Oh, these appear to be videos. Okay, I know which one it was. It was one I said that doesn't exist. Okay. As you can see, I got a lot of data to share with you guys. Share some with you, and I didn't share it all. It's a video. I wanted the image of it. These MOVs are movies. There's no reason to. You guys have seen most of them. Some of them not, but. Oh, this is VSL. My research on VSL, their systems. For example, this is a system they use, and I talked to you about. These are zones. This is proprietary stuff. This is nothing I can give you an answer on, because the manufacturer decides how this is installed. With that said, and why, and things like that, and there's deducting. With that said, this is also this area here, this zone here. This is, that's their zone. That's what you would talk to them about. They would own this. The engineer would not own it. They would own it. The VSL engineer would own that area. This is really nothing you guys really would care about. that would be a long video about nothing proprietary and proprietary stuff anyway. I seem to have lost my place this time. I'm in the right location. And I'm underestimating where I am. I hope I'm not down here. Yep, looks like I was talking to you. It looks like I already started doing a video on that. Sucked in by new moment of tendon, pulling it down. We see it as a tension failure in video. So what the hell I'm talking about? I know, it's the, I made my own wording here. Tendon pulling on canopy to point of no return. You're looking at my notes live, so let me, and I didn't share this one, obviously. It's just theories, and sometimes I write them down and then I work on them afterwards. No, number 11. So we see that's what it was. Number 11, we see that number 11 in the original 2016 stamp drawings, which we do have access to with 2016 drawings, this had no post-tensioning post-tensioning in it. At one point, make sure you guys are there. The audio doesn't go out. At one point, I think when he sent it over to get it checked out by the other engineer, I'm bonking. You know what bonking is, guys? When you're running out of juice. I wish I had something a little sweet around here or something. I got nothing. So anyway, because I didn't eat it all. I haven't had breakfast or anything. And I've been up since, what, 7:30? 7:30 running around. Got up like 6:30 reading, and then so now I'm working on, I like to see what's going on in my brain too. Now let's see if I can tell my brain that and I'll recover. All right, because I know what I want to say, but it's not coming out. The consulting engineer is what I wanted to say, that word. So the consulting engineer, should I just tell him? The consulting engineer, what you got here? Yeah, no, I want to finish this and wrap it up. So the consulting engineer, thanks, I think told him that, or said, look, I think you got to add some, well, let's look at it this way. Number 11 is designed to be in compression only because there's no tension members in it. There's no resistive forces planned at this point. Even if these are not the stamp plans, these are an intent. And the intent are no post-tensioning bars to be in number 11, so no compressive forces are added there because compressive forces will be automatically driven down. I did the highlighting here, guys, not this. This is a screenshot from me after I do my highlighting. So the force is going down. Now, when he went to the consulting engineer, he looked at the plans and said, yeah, he did a couple of changes I noticed. One, he moved as everybody got upset initially that the transporters were on the outside. And so therefore the bridge, and when they found the bridge being moved, it was in the inside. Therefore, this was all wrong. And everybody stayed quiet on it, all the people. But reality, because if you answer one question, you got to keep answering questions, guys. That's why they don't want to answer them. But reality, when the 2017 plans were released, we see that the transporters were moved inbound. And also post-tensioning was added to number 11 and number 2 being already there, having 4 members. So it was added into number 11. Now the transporters were here on this one. On this one, they were in a different location. This was off, but I don't think it was that critical with the post-tensioning. I don't think that caused all this failure. Maybe you can try to do that, and then you can blame it all on there. But the reason why I think that is because that you can't think that, because it was failing inbound. It was failing at the inbound at the impound. Here's our first, these are pores, so this is not where it's actually center lines. If I could blow that up, it would look like, sort of like this, the way these architect's drawings show. I can't find it. And remember, this was the first drawings that had 3, and if you recall, I bitched and moaned about, wow, these are so outward bound that they should put them closer, and how do you tie it in on an arch? They're all going to be, you're going to use steel, because I couldn't figure out how to tie the post-tensioning cable transverse cables in without going crazy, doing 175 feet of them. And incidentally, they did no transverse cables, as far as I know, down here, just steel. And they did add the other member. Also thought they should have one down the middle here, but that turns out where they went with their drainage to transfer the loads directly out. Now the transfers is 1'9", which they call 12'6". Okay. 12, yeah, bonking on your asses. 12'6" is the total width. This is 1'9", here and here. 1'9". Let me try to see if there's 1'9" here. I can't find it, but nevertheless, this is 1'9". I showed you in the previous comments this concrete has to take the load and transfer out to these guys, to the tops of them. And they do that with the transverse cables, but remember, there are pockets that these have to go through, here and here. That if this is sitting here, these are the cables represented by these points. 1'9" spacing. If they're the cables represented by these points, you've got this void. Wow, this is a nice indicator showing the void. The load path of all the entire bridge structure going down the center of this. Wanting to fold it in, like if you had your hand out and you put your other hand, make your hand flat and strong, like all your fingers out, like a strong, straight handshake. And then take your right hand, do the same thing, and this time make it a T. And now push into the center of your hand. You see that it would buckle in. The two outsides would fold in, would buckle in. This is what they created here. They designed it perfectly to buckle in my opinion. I shared this with a couple of engineers, bridge engineers that build bridges. And they both said, yeah, I see your fucking point. That the center of this is all the loads in the canopy come down to the center of this bridge, allowing this to just fold in like a fucking butterfly. But it didn't fail in that capacity. So so what? On the terms of the procurement, here we are. Here, the firm selected Lewis Berger was not FDOT. Well, that was just some. I don't care. That shit was going to fail. Here's this other end of post tension cable with NCAT. I did that one in. There we go. They load tested it. They load tested it with the dead weight only. They load tested the span dead weight. Right here is where we'd want to see more of a hinge action, pulling away. Not there's so much of a 90 degree. We do see something going on there. That might be that spalding from before. But if this was being pushed away as they theorized, then this would sheared. This would also have a lever action, breaking this, compressing this up. I'm sorry, this should be tension here, pulling away and compressing up here. Got it. This shows clearly this pushing away. So this was forced away as it's falling down, and there's your break. Coming to rest, not together. This came to rest together. This reinforcement is keeping apart, or it's being held up by something else. Okay, moving on. This was originally my 2016 evaluation stuff back in March 21st. So you're looking at my brain in March 21st. No tendon specified. These degrees are different that I was finding. This thing is just, it's not balanced. Canal side not built yet. But wrong design and field of upright under same. We are thrilled to have performed this as BDI. They're the structural monitoring. They did the structural monitoring of the bridge move. Don't get that confused with bolts or FIG or MCM or FIU or anybody else. They are BDI. We are thrilled to have performed the structural monitoring during. They're the ones that added all those monitorings, etc. This is what you would need to see. You'd find out what's going on. Congratulations to BCR. Right here, Barnett, these people that did transporting on a job well done. We always appreciate being part of the team. Here's the thing, though. This whole bridge should have been designed with this company in mind. This is what FDOT, what the federal government recommends also that, well, the federal government recommends it. All the states recommend it. This recommending bullshit is just bullshit. They need to get away from recommending and make it mandatory. They were supposed to be involved. They would have been able to tell you the load points, but they did it did the load points themselves. This same company, FIG, I believe, I don't believe, or MCM, that they moved it around because bolts, after it came back with the new stamp, it came back with bolts with the new location of this. Bolts, I'm correcting. Lewisburger. When it came back from Lewisburger, they moved these guys. Only people should be moving these is this company, Barnett Crane. They're the only ones that should be looking at this drawing, the structural engineering of it and everything, and say, hey, we need to put them here or here, or if you want us to move your structure as is, we need to add 6 more of these guys, not 2. So after the fact, you can move any goddamn thing you want if you get enough, support around it. So they stuck to the plans apparently that apparently, and I'm speculating, and I nail it sometimes in my speculation. Apparently that Lewisburger said move it inbound, add the post tensioning to number 11 for the cantilever, and Bart Harnett agreed with Lewisburger's positioning of this because that's where they wound up, save this one was to the right or left, just off a few feet. I find it interesting that he nailed it. I would not have been able to nail this. I like playing with it. I would have over nailed it. I would have added more. It'd have been a lot less load on these guys. I would have had a lot more cranes come out. These guys come out. These transporters come out. At a higher dollar, of course, but then I would have been fired. Nothing to see at the point. This is after the bridge is in place. This is the south end, if that's the north end, I believe, because it's the labeling. That's how I'm determining it by nothing else, guys. I just see sky. I don't, I could be wrong. But there's the pipes, and there's the void in the pipe. So we know that it wasn't even solid filled and removed later. So your loads are coming down the side of here. This is where, so let's say it's that end. It could be the other end, but it's still symmetrical. This is where the other post tensioning bar is that the crack happened. So we're looking at this one. This is next to this. This is that duct. This is the plumbing. That's that drain. Right about there is where the crack is above us now when we look at it. And that's just for reference. Somebody sent me this. And somebody else sent me that. No, one of the guys sent me that. One of you guys, and I just throw it over. When you send me from here, I tie it over from here to there, showing how conversations transferring. That's why it's there. Except for the other one. This is a few days after the accident. All this truss plate design. And I got this backwards. See this end? It's this end. I got my north end and south end. When I was looking at this, I thought this was the north end. And I did delete that video. I did talk about it. And this video got deleted. I totally thought this was the north end and south end. So this, if you invert it, guys, this is that one. Everything I'm saying here is this side. Workers observed and posted. I said workers observed. It's really on this end, right? Unknown but vertical, but verified the crack observed by FIU and builder and engineer. Okay. Approximate point of tension failure. And so this one would be here instead of there. Not good. Typical, meaning typical. I'm saying the wording, but not good. All right, so you guys saw that. And what am I saying here? Oh, okay, so this appears, this is, well, same day. Yeah. At the time, if the timeline's true, 12/27 is when I got that backwards, and then I don't know if that's AM or PM. And now just 20 minutes later, I've got this 20 minutes earlier, I got this going on. Appears to be primary point of failure from post-tensioning worker observed location. Appears to be the smallest truss plate, this is. When I did the math on all these guys, these are smallest truss plates. Yet to be disclosed where existing crack was or, and details the same. Typical, not good. Zero tension. Would this cause upper cord to fail at this location? Oh, so that was my theory at the time, that if this had no tension on it, would this cause this to fail? This is on March 19th that I'm speculating about this. What happens if you had, that's good. So I'm speculating, I don't see this obviously on March 19th. Let me see if you guys are there. But it appears I was speculating back on March 19th, just a few days after the accident, what would happen if, as I said, zero tension? Would this cause upper cord to fail at this location? Approximate point of tension failure appears to be secondary, lower cord failure. Approximate point of failure appears to be secondary. So this should be here, not here. So I'm doing that inversion thing I did with the minute of the same video a second ago. Except for clarity, I think that I did think it was here when I saw the video, and then after looking at it later in time, I clearly see it here. So even though I'm thinking that this might, I don't think it's the same as me making a mistake like this. I think I might have thought it was here and not here. You know, maybe I did invert it my eyes and did that. But I'll let you guys see inside of my little peanut. Possible total tension failure on this end of member as upper end not look damaged. Possible total tension failure on this end of member. So I'm saying this is the entire member and this is the half. And I'm saying it's a tension failure at this end of member as upper end did not look damaged. Remember, I'm only looking at the photographs. At this time, I don't think we have a video at all. And so I'm calling it a tension failure. Oh, I know exactly why I did this. That I divided the half to here. I just did a half on this one. And I speculated that the failure would be here. We don't have a video at all at this point. I don't have access to the video. I didn't see it. I don't think. Because I divided in half, and half is usually your weakest point. And that's just half. It's 87.5 and a quarter. That's half. But this one I have over here. And I did this. This is interesting. I caught on back then, you know, now looking in hindsight. Would this cause zero tension? Would this cause failure in the upper cord? And sure enough, it would cause failure in upper cord because the loads wouldn't transfer down 11 anymore. And it would cause failure in both upper cord and lower cord. Wow, I could SMD myself on that. You guys know what SMD? I'm not talking. I'm looking. You guys already seen this stuff, so I'm bouncing. Okay, yeah, so the original transporters were, and they moved them in. So this structural engineer, I don't know if he's in here. He was saying with a harmonic, even though they were the stays and pylon provide the required structural design to meet the pedestrian loads for harmonic conditioning of. So they were structural, guys. Those that they were not just faux, they were structural, but they were also a dead load. I think I mentioned that in another video. Those damn pipes. I'm racing through this stuff because it's I don't think we're going anywhere else with this. And this is where I think I got it backwards. Looking at this is the end that I thought was the end. It failed, but that drove me crazy because of this. But then this made me think that this was the temporary structure, and they were rolling around on it. Anyway, that doesn't matter. Okay. This is the it clashed on the 15th, right? Not the 18th. This is 3 days later. Reverse lights on, lucky witness. Lanyard, hydraulic tooling. What I'm pointing out there. I'm reading. I'm not talking. That was some of the lighting design. I had it was getting confused. The drawings had lighting design. It was important. Cabling, stuff like that. Making voids. I think I should end it with this. This project, because I think this, I didn't finish reading it, but I think this is the one. This project's success depends on outstanding pedestrian, on an outstanding pedestrian bridge. While the plaza and walkway is important, the top priority is the bridge design. In other words, if we get the bridge right, everything else can fall into place. If we get the bridge wrong, nothing else will matter. I mean, you couldn't pick better words than the video on now. Hey guys, it's 3 o'clock. That means 4 hours. My ass is done. Now, should I leave this video up or tear it the hell down? I just want to do a live chat. Is it going to be conflicting the previous video because this is 4 hours long? Who's the hell? Is anyone going to watch this? You know, is anyone going to watch it? Or do I just put it private and let it throw it in the shit can? Leave it on. Can I get a, that's the, what do you call it? The first, can I get a second on that? Anybody going to second that? Or do I, one person says take it down. I'll take it down. I'll leave it down. I need another person to say leave it on now. So we know the outcome already. So, yeah. Oh, Doss second himself. Hey, leave it. You'd watch the cognitive, man, you got to watch this thing in like group sessions. You know, I could break it down, right? Take it down. I mean, take it down, download it, and then put it out in sections. I guess put it in 40-minute sections. What's that for a thought? That would take 10 sections. Oh my gosh. Even I would get tired of seeing 10 sessions. 4 hours, you just keep coming back to it. I could leave it on just for any students or something that want to look at it. They can critique my mind. They can critique whether he's wrong because this would be hindsight stuff. Cool, Rick. Yeah. Thank you. Yeah, cognitive. Yeah. So I'll leave it on then. Thank you. Which case all I do is hang up now and it actually stays on. It takes a while to, it'll take a while to buffer it and step it up to 320 or 680, whatever the hell it's going to load it up to. This is on Google's terms. Hey, I'm ready. I'm ready now. I'm actually saying goodbye to everybody. Oh, wow. I know, 4 hours. 4 hours. I know. I need to. They told me I should leave it on though for 4 hour video. They said they'd watch it, so I'm gonna leave it up. So you got to hear me talk to my boss there. That's my girl, right? I can pretend like I'm the boss. All guys pretend like they're the boss. But look, you tell me when a girl doesn't get what they want. The girl you're dating, the girl you're with. They ultimately get everything they want. You can bitch and moan and claw like a little wild cat, but they're gonna get what they want, and you're gonna be happy giving it to them. I am. That's why I got even. I'm just happy to give it to her whenever I can, because I know I'm gonna give in any damn way. Thanks, Hermit. Thanks, Hermit. And I'm really teasing you about the let me down on your technical research abilities. You're allowed to do what you want to do, man. All right, everybody else, I got to end it with that I love you stuff because it's been a great video. We spent 4 hours together. You know, at least got to give you a little hug and a kiss, a little tap on the ass for all the guys. And that's all you get. CSS. I'm going to do, I was going to go to a bridge. I think, yeah. Stop talking. I'm trying to find a hang up. You can play back 2,000 speed. Priceless. Thanks a lot. Bye.